All right, so I think we have a quorum now, so we'll get started. Hope everybody had a good lunch. I just wanted to remind everybody that after the class is over, we're having the poster session this afternoon, about from 4:30 to 6:30. And then after the poster session, they're going to have the Mardi Gras thing at Brazos Hall. There'll be music, food, drinks, so everybody's welcome. Just want to make sure to do that before we get started. Okay. So we've talked about what a flare is, what goes to the flare, the monitoring that goes on a flare, what you do with that data from a flare. And now we're going to say, let's try to control something on this flare using that information. So there's some discussion, well, there's a ton of discussion on all these things. We're going to go over just a couple of different scenarios that people have encountered before. One of the things is where is this control system done? Typically at facilities, if it's a process-related control, it's all being handled inside the DCS. We're finding a lot of people that when we're doing these control systems, that you're looking at a significant number of additional tags that are going to have to be created for this system. We've sat around and not thought of all the different tags we could think of. And you're looking at least 50 to maybe 150 new tags to implement this. So I mean, when you think in your head, okay, we just got to adjust steam, and supplemental fuel, it's not an easy process. I mean, there's a significant amount of engineering and programming that's going to have to be done. But a lot of people have done it inside the DCS. Some people have thought about doing it external to the DCS in some sort of a data acquisition system, and then feeding the important parts back to the DCS just to minimize that, because especially at some of the older facilities, the DCS is already maxed out and they can't handle it. They'll bog it down. So they're saying we want a way to have it external and then just only feed those parameters that an operator would actually have to know when something's going wrong.
Another possibility would be to take it and feed it the pie.
Usually the pie is after the fact, that's the historian.
Yeah, well, it's the data historian, but instead of feeding it to DCS, you feed it the pie, and then you get in there and analyze it.
Well, post-process, yeah, usually, I mean, it's because it's active control. It's got to be the live data. Yeah, so it's not, you can't, well, we wouldn't suggest trying to do it post-processing or after the fact. It's best to be dealing with the live data, and that makes it. Basically. Mm-hmm. Yeah, no, it is a big issue, and just how different people have handled it. It's been typically in the DCS. But one of the things that we're trying to do through the control is we're controlling multiple parameters. So I mean, it's multiple steps of logic that you have to say, yes, I'm meaning this, yes, I'm meaning this, and yes, I'm meaning this. Some of them help each other out, but there will be times that you will have to go beyond one step of control when you're good for some, but need to go farther for others. So, and when we talk about control and this concept of automatic control versus manual control, that's kind of an artifact of consent decrees. Because with the consent decree, you get requirements for monitoring and being in automatic control. If you're not in automatic control, you get a certain number of hours a quarter, and then if you're out of automatic control, you get stipulated penalties. So this concept of being in automatic or being in manual becomes very critical when you suddenly dollars are going to start flying out the door. So that's where we talk about, are you in automatic, or are you real, or is there some manual function to this?
Consent decrees that you're talking about, do they specify what automatic control means?
Mm-hmm.
And is it the combustion zone that has to be automated?
Yes. The only thing that is not, and we'll get to this, is not the truly fully automated system, is the steam control, because it's based off of smoking, and currently there's no real analytical technique to get a direct smoking reading, so that there will always be chance for the operator to adjust the smoking. For consent decrees, it's that 3-to-1 ratio. As long as they haven't adjusted it beyond 3-to-1, they are still considered in automatic control. But if you have a big event, it's something that's smoking really bad, and they got to go past 3-to-1, which they are allowed to do, then they're out of automatic, they're in manual, and the clock starts ticking. So it's a strange little thing, but yeah. And so luckily, NSPSGA, you don't have the control issue. So it's right now it's a consent decree and future MACT issue. So right now, as we already said, ops has one thing to control. They have steam. Well, now you're going to put in a supplemental fuel gas line with a control valve. So now they're going to have 2 buttons. So they're going to have steam or supplemental fuel. The supplemental fuel basically comes into the equation here because it kind of gets added in similarly to the vent gas. And so you're basically just going to pump up how much net heating value you have going in the vent gas to get yourself into compliance. One of the big questions that comes up is, where do you put your supplemental fuel versus your analyzers? This affects the logic. Are you putting in your supplemental fuel downstream of your vent gas flow meter? Are you putting it in upstream of your flow meter, so then that vent gas meter sees the flow of the supplemental fuel? Same with your composition analyzers. Do you want the composition analyzer to see the flow of supplemental fuel, or do you not want it to see the supplemental fuel? And this is going to affect how the calculations are in the DCS and how you run your system. Other issues that make control of your system a little difficult is just when you're getting data back, and you've calibrated for certain components, and then those components you get a component that wasn't calibrated for. So now you have a peak that you don't have it programmed in as to what that is. How do you deal with that situation? Is close good enough? There isn't any real guidance from the consent decrees as to how close you need to be with these measurements. You have to be so accurate on they have an accuracy requirement on each analysis, and they specify the components. But if you find an outlier, how do you handle that when everything's not adding up to 100%? One other thing is here, and when we talk about, especially like with GCs and the runtime, there's a lot of we hear a lot of people say, well, we'd like to just speed it up. How can you speed up the GC, and increasing carrier gas rates, maybe messing with the oven temperatures? Generally, this isn't the best solution, just because you can end up getting worse peak resolution as things get mashed together. You really want that good peak resolution so that you can know what all those compounds are. Averaging times. This concept came into with the marathon implementation. you know, was a big hurdle that they struggled with, was just getting all the timing worked out. Is because, you know, flaring, you know, especially if you have a flare event that's going to last 4 minutes, and you have a GC or some other device that's going to take a sample and give you a result 10 minutes later, it makes it kind of difficult to control off that. And so, you know, we've done some different, just some modeling of how those analytical times versus adding supplemental fuel time. And when you're getting, because also you're grabbing a sample when you're getting a result. So, you know, those times are very close together, so that you get a result that may tell you to add supplemental fuel, but then you've already grabbed the next sample for the next 15 minutes. So even though you knew that you needed supplemental fuel, and maybe you start adding it, the next analysis you get will not have the supplemental fuel in it. So then it's going back to that time that your data may show you being out of compliance gets compounded over multiple 15-minute segments. You get this in all these, and this is not only a JA issue where you have you have your sulfur limit is on a 3-hour rolling basis. The consent decrees are full of different hourly block averages, rolling averages. You know, is it a 5-minute block? Is it an hour rolling? Is it a 24-hour rolling? You know, they just go all over the place. And so that's where, you know, that's where we recommend that when you're pulling the data, don't do any data reduction on the front end. Get all your data out of your monitors, and then so you can, for compliance purpose, for control purposes, you're going to use that live data. But for your compliance purposes, you're going to need that more fine-grained information in order to do all the different averaging periods. So definitely take all that information back to the historian. Steam to vent gas ratio. This is relatively straightforward when it comes to control. Especially if you have a ultrasonic flow meter. The ultrasonic flow meter has the nice principle in that it can give you molecular weight, average molecular weight for the stream. So it will give you directly a pound-per-hour number going down your header. You can just easily tie that to your steam flow meter, which will give you pounds per hour. And now it's quite easy to set up a ratio control for pounds to pound steam to vent gas. If you weren't able to put in an ultrasonic and you had a optical flow meter, now this is more difficult. I think it was for Marathon's consent decree, they were given the option of using either steam to vent gas ratio on a mass or a volume basis. That's pretty much gone away with the more recent consent decrees. They're all on a mass to mass basis, so they've removed that volume number. When you're looking at this molecular weight number, you know, we definitely recommend the molecular weight coming from like the GE flow meter, just because when you're doing it again by a GC, which will give you that composition where you can calculate a molecular weight of the mixture, it again is not on that time frequency that you need for control. I know one of the Marathon refiners, when they were trying to implement that, they couldn't get the control strategy to work using the molecular weight from the GC. They had to switch over to the flow meter. And so that was, because you just need that. It's going to be changing. Your vent gas is going to be going all over the place, and so you need that more rapid control for the steam to vent gas ratio control. Okay, this was another learning moment for everybody. One of the things that we find is it's easy to add gas. It's really easy to do all the logic to set it up to add more supplemental fuel. It's the harder thing is to get the system set up to remove supplemental gas. And when you start paying the bills for all that supplemental gas, there's going to be a big push to reduce as much supplemental gas as you can. So that's where you know, you want to do that logic right. But one of the things is here's the situation where you have your vent gas flow is increasing, so then you got a ratio controlled, so your steam is increasing. Well, what if it was a lower BTU gas? So suddenly, now your steam's increased, suddenly you're having a poor net heating value in the combustion zone. So then they open up the supplemental fuel. Well, what'd that do? That increased your vent gas. Well, that increased your steam because they're ratio controlled. So now you have these two controllers that are basically walking each other up because each one increases due to the other one. So then you're going to walk into the control room and find one of those valves at 100% because it's basically been walked up to that point. So that's one of these cases where we recommend that you put the supplemental fuel gas addition downstream of the analyzer. That way you can always have a true hard number coming from the vent gas to tell you what's in the gas, so you can know I have 600 BTU per scuff in the vent gas. I don't need any supplemental fuel. You're not wondering, okay, I have, you basically have to back it out because you're like, okay, if it's upstream, you say, I have this supplemental gas that's mixed into here. I have, say, 650 BTU per scuff, but you then have to back calculate and say, well, how much of that is due to the supplemental fuel? And so you're having to take that out, and that's just makes it a little more difficult instead of just saying, I know what's in my vent gas, I can keep moving because I know I can shut it all the way off. Our friend, momentum flux ratio. I'm going to spend very little time on this. Basically, it's the ratio of how much momentum is going up out of the stack versus the crosswind. If you want ever forced to do this, yes, you will need a MET station to get wind speed. That's the only way to do this. Some of the consenters have been required to put them in. Basically, there's two ways. If you get low MFR, there's two ways to control for it. Either increase your center steam to get more upward momentum to push that flame up, or increase supplemental fuel to, again, increase that velocity. We generally say don't increase your center steam because what are you doing when you increase center steam? You're just diluting that heat content, so then you're likely going to need supplemental fuel to correct for the net heating value, so you would just increase your supplemental fuel to start with. Okay, so some of the consenters have had, you got to think that there's multiple reasons to add supplemental fuel. You have just to meet your combustion zone limits. You could be adding supplemental fuel to stay above your 300 BTUs per scuff. This especially comes into play during maintenance events. A lot of times you're steaming out a vessel, or you're purging with nitrogen, sending all that gas to the flare. You could end up with a low heat content in your vent gas. You're going to then be adding also supplemental fuel to make sure your MFR is okay. And we through the enforcement, the number for MFR is 4 digits, and yes, the last 0 matters. We found that out, and we were very surprised, but yes, they were concerned about the last 0. Another case where we've seen people adding additional supplemental fuel to their flare is this kind of emergency high temperature releases. We've seen this mainly on very large flares. So say you have a large release of very hot gases into your flare header. You know, it's going up the flare, it's burning nicely, but then it's over. The flaring event ends. And you have this just little slow purge gas rate that's going to go in and clear your header. Well, if it's a cold day, you could have, thermal contraction of those gases in your header. They're contracting faster than you're adding purge gas. Suddenly you're creating a low pressure, and you could suck oxygen down the tip, suddenly creating a combustible atmosphere. Again, say you had some, then it gets up to your pilots, and boom, you've just ignited your flare stack. So we've seen where facilities have added in this kind of emergency case supplemental fuel where after they've had either a high temperature release or a release of significant duration, they will have supplemental fuel gas lines that purge out the flare for like 15 minutes. They'll just dump a ton of natural gas into the flare to basically push out any hot gases that are in those flares, just for this safety case. And here's that thing about the steam to vent gas control being automatic is, so the goal is always to keep the least amount of steam or air on your flare at all times without smoking. If your process is relatively consistent, you know, in the beginning shakedown phase, you'll figure out maybe, okay, we can run nicely at a ratio of 0.5 to 1. And you're like, okay, so it's going fine. And then something happens and the vent gas goes up, but then it's starting to smoke a little bit. Well, the system doesn't know it's smoking. The system just knows to try to keep it to 0.5 to 1. So then what's the operator going to do? He's going to say, well, I'm not going to smoke my flare. So maybe he's going to increase that steam to vent gas ratio up to maybe 1 to 1. Maybe that takes care of the smoking, maybe it doesn't. But he's allowed to make that change under the rules. And he can even take it if it keeps smoking. I mean, maybe it goes all the way up to 3 to 1. And basically says, does that take care of the issue? And then he's still in automatic control. But there is, while we call it in automatic control, it is still manually being set by the operator. But if it goes beyond the 3 to 1, then you're going to be out of automatic and into manual, and the clock starts ticking. So while they call it automatic, with smoking, it's still a visual manual thing. So, but as we said, just to reiterate, we want to control all these moving pieces and keep yourself as close to that incipient smoke point as possible. And from the preamble to Max CC, you see them making comments like, this increased monitoring and control will make it easier for you to be as close as possible to your incipient smoke point without smoking. So it's definitely the EPA's perception that having this sort of control scenario will allow you to operate your flare in this manner. Okay, just to kind of, this is just an illustration. This is a partial list of, you know, we've put together a few of these DCS calculation manuals to look at, you know, you have various parameters, you know, all in different units. Where's that coming from? And some of the things is you start thinking about, okay, what happens if something, a tag goes bad? What if the pressure transducer on your flow meter that's correcting the standard condition goes bad? Are you still in control? You know, from a consent decree, there's that monitor uptime requirement. You only have so many hours a quarter that you can be not having a functioning monitor. So now you got, what do? Like, you need the rest of your system to keep working, and just because you lost your pressure measurement, you don't want to have to shut everything on automatic. You want to be able to let it function. So is there a value that you can use that can keep the system functioning well? Maybe not the best, but at least good enough to keep things moving? Or is it just basically a critical failure where you cannot operate without that parameter? So that's kind of a case-by-case situation, because a lot of times with some of these meters, they're not just working fine and then all of a sudden don't work. They'll sort of drag down over time, and there'll be a slow decline in that response factor, and suddenly you don't know how long you've been out. So it's not like, you know, oh, I've been at this one reading for a month now. I know it should be that. Over the last month, you could have been slowly declining, so you don't really know where to put that value. So that's something that you would have to do that rationale around. Then there's also thinking about all the different averaging times, and also from those calculations, you saw that these tags, are interrelated between all the different equations. So if you lose one tag that you may think, oh, that's just one tag, well, that's going to impact another variable that then impacts another equation. So now you have something cascading through the system, potentially throwing everything out of whack. So it can get rather cumbersome. One of the things when you're setting up your control logic is trying to understand where is the data coming from, where is the data going, where are the calculations occurring. This was at a specific refinery. This isn't like everybody's. It's just how a certain refiner did it. And you can just see that they had different analyzers, feeding different types of information. Some did the calculations in like a PLC. Other ones, and all the data basically was going into not only the DCS, but it was also going into a DOS, and then finally going into Pi. So I mean, it's where do you want to have that data? Who's doing the calculations? And just so you know that everything you need is being stored for your compliance purposes. So it's another activity that it's good to understand, because we'll be talking to the environmental staff, and they'll be like, okay, well, we get this number, like we got this number in the DCS, and it's like, okay, where's that coming from? And we're like, is that calculated in the DCS, or is it coming out of the instrument? And they'll be like, well, I'm not really sure. And then you go back and you say, okay, yeah, it's coming from the instrument. And it's like, what molecular or what net heating values are they using? Well, we don't know. We're going to have to go back and now figure that out. So I mean, it's working through all those data points to be able to know, so that you have comfort saying that, yes, we are in compliance with, if we're under an enforcement action, somebody's going to be looking to you to say, are we in compliance? And it's good to have that comfort level with your data. Here is some actual data that was presented by Ruth Cade at Marathon at AFPM. So this is early on in their consent decree implementation. And so it just we just like this data just because, hey, it's real data. We know people like to see real data, but it also illustrates some interesting things. One of the things that so you see when the vent gas goes up, you see that the steam, you see that there's a little bit of a lag, and you're going to want that, some amount of lag, just because if you had your steam flow meter change position every single time you get a new flow meter reading, that flow meter, that control valve is going to never stop moving. It's always going to be trying to get to some new set point. So to keep your control valve from just going crazy, you want to be able to know that is this a half a second spike, or is this an actual sustained trend that I need to now control for. One other thing is you can see, so it's also trending. Vent gas goes up, steam flow increases. Suddenly the event's over. Steam was still up. You're coming back down, and then you might say that for some reason, I forget there was a reason why the steam came back up, and suddenly you're dropping in net heating value. So what happens? Suddenly your natural gas kicks in, says, I need to make sure that I'm going to stay above my net heating value target. So then the natural gas comes up, the system's able to come back down, and then the natural gas backs off and pulls itself out of the system. So I mean, this shows an early case of that control, but it does show that, yes, this type of control is viable. Oh, I guess I forgot we animated that. Okay, so just things to think about when you're going to need to integrate this thing. It will take significant time. I was talking to a guy just last night, and he said that working out some of their steam control issues, he was saying it was over 100 hours of effort to work out some of the kinks in the control logic. So I mean, it's definitely a thing where you're going to have to get your system understand each piece of the system, because I mean, you're going to be having to tune all these valves. I mean, there's going to be significant time around this. Everything's got to be corrected to STP. Make sure everything's in the right units. You're going to have to make sure that you have things to use for data validity. One other thing I forgot to mention was on that, you know, when you think about those temperature and pressure probes, if you're in an enforcement type situation and you could get stipulated penalties from these meters, a lot of folks have started to go to put a sense of redundancy in their system. They don't ever want to get stipulated penalties because they didn't have a pressure probe. So basically they've gone to I'm going to install 3 pressure probes, 3 temperature probes on their flare header. Use a voting system so that as long as 2 of the readings are within a certain amount of each other, I know that I have a good temperature reading. If that third one is consistently out, it's now been flagged for maintenance. So you should, hopefully with 3, you should never have a situation where your temperature probe, where you're going to have a data issue due to a temperature probe. So I mean, people are going, and that just is increasing the number of taps you're going to need on your header. So I mean, especially if you aren't taking a shutdown and people are talking about hot taps, you start saying, you know, I want to put in a flow meter, and you're looking at, 10 hot taps. That's going to get people's attention at $10,000 to $15,000 a hot tap. You're getting into real money. So it's something to think about. And then just look at all your data flows and making sure that you're getting everything in the right time frames in order to calculate all your averaging periods. Yeah, one other thing to think about too is once you do all this stuff, then you also have to think about your alarms. When do you need to tell the operator that the automatic system is not going to work? We need you to do something. And so that's a whole nother set of logic to be able to tell the operator, hey, pay attention to me. I need you to adjust something. All right, any questions? All right. So we're going to move now into the regulatory side. So we're going to kick off with NSPS JA. I know not everybody in here is a refiner. We just like to, even if you're not a refiner, we still think that there are some good lessons learned, just because you start seeing trends in what EPA is asking for. So you can kind of think of, as new rules come out, what are you going to probably see coming out of that, and what should you start thinking about? Okay, so NSPS JA, applicable only to petroleum refineries. It is an NSPS, so it has the new reconstructed or modification trigger. If you don't trigger it, you're not subject. You know, they've changed some of these modification definitions. So basically EPA, they had NSPS J, and they thought that that was going to be able to reduce SO2 emissions from flares. They found that not enough facilities were becoming subject to J. So they wanted a way, and they weren't getting SO2 reductions, so they needed a way to pull more facilities into the regulation to reduce SO2 emissions. So what they did was they came out and they separated flares out of the fuel gas combustion device category. So it used to be everything just, if it burns fuel, it's in a category. Well, now they said there's still that category, but we're saying flares are different. One of the other things that they did, and this was how they're going to get probably every refinery flare into JA at some point, is they expanded the definition of flares to not only be the flare stack. Now they're saying the flare is everything from the flare stack to the seal drum to the knockout drum to the entire header. That way, if you add a single connection, you've increased the flow potential to that flare, which has increased the potential emissions from that flare, and therefore you have modified that flare. Welcome to JA. Most refiners, they go in and say, well, we probably made some changes, so we're going to take it anyway, because they don't want to have one sample tap put them into JA. They don't want to go and say, oh, shoot, we installed a closed-loop sampler as a part of this project and nobody told us. Oh, well, now we've been out of compliance. Nobody wants that. So there's a lot of people that have said, even though I can't prove where I triggered JA, I'm going to take JA applicability anyway. Because we think it also would be a rigorous exercise to be able to prove that you didn't. So, I mean, it'd be a thorough MOC review, and just the potential for something to have happened without you knowing is pretty high. So we think everybody is going to be pulled into this rule. The rule basically adds increased monitoring requirements and some limits for those. One of the big things is we've been talking a lot about combustion efficiency. This rule has nothing to do with combustion efficiency. It's an NSPS, criteria pollutants. It cares about SO2 emissions. Only way to reduce SO2 emissions from a flare is put less sulfur to the flare. So it doesn't care how it burns, it just cares what's getting sent to it. Major items. Install a flow monitor and install a sulfur monitor. I mean, how hard is that? It's very hard. I mean, there have been a lot of people working a lot of time and a lot of effort and even redesigns of equipment, with the, the T17s to be able to meet this rule. So, I mean, the rule got finalized back in September 12th of 2012. There are people that are still haven't ordered their equipment because they haven't been able to decide what to put in. So it is taking the whole 3 years to come into compliance. Another part of the plan or the rule is you need to put together a flare management plan. This becomes a theme with all these regulations. You got a regulation, you got to have a plan. Okay, because you got to be able to have a way to document what you're doing, how you're complying. So the management plan is going to be something that you have to do. The flare management plan basically has, two sides to it. It has a side that says, what do you have? Tell me the specifics of your flare system. And then the bigger part is the minimization assessment. You are required to go and do a minimization assessment of your flare to see if it's possible to reduce the flow to your flare. Then it also gives you, there's a driver to conduct root cause analyses if you exceed those thresholds. It's very similar to the root cause analyses for consent decrees. So most refiners are pretty comfortable with this process, but it just has a few subtle differences. And then there's the requirement for also doing corrective action analyses after the root cause analyses. Okay, the flow monitor. Biggest thing they added was must be maintainable online. At least they recognize that they don't want you to be able to say, well, I can't do the preventative maintenance on this flow meter because I'd have to take the flare down to be able to pull those probes out. So they said, okay, well, if you put a flow meter on here, you have to be able to pull those probes out without shutting down your flare. It's actually not that difficult to do. It's basically you're installing to the GE ultrasonics, basically you're installing a valve right off the tap, got a valve where the flow meter can retract back beyond that valve. You can shut the valve and then get to the flow meter. So it is possible. You must correct to, you need to measure pressure and temperature so you can correct the STP. The flow meter has a requirement for a quarterly visual inspection. That is basically to check the wires to make sure you don't have any breaks in the wires or frayed wires, things of this nature. If you don't want to have to do that, if you install redundant sets of transducers, you do not have to do the quarterly visual inspection. They put the word in here, recalibrate biennially. With an ultrasonic flow meter, there is nothing to calibrate. There's no response factor you're tweaking, there's nothing. It's a solid state technology. Either it works or it doesn't work. So then we're waiting to see whether or not that word recalibrate ever comes into question. Because what they do is they'll do a flow verification and flow validation once a year. Which is also, they say, unless otherwise specified by the manufacturer, all the devices that we have talked about today, they all come with an annual requirement for verification. So what, predominantly GE does, they'll come out to your site, they'll pull out the transducers, they'll check to make sure they're not covered in crud. They'll put them into a zero flow box, measure that zero flow, check a bunch of diagnostics. As long as those diagnostics match up close enough to when it left the manufacturing center, they'll put them back in the flare header, run some more diagnostics. As long as everything checks out, you're good. That's all they do. So, I mean, there's no testing it against a flowing media or anything like that. Okay. For the root cause analyses, there's two triggers. One is for SO2 emissions. Anytime you have 500 pounds in a 24-hour period, you have exceeded it. Or if you have 500,000 scuff above a baseline. This was, again, a difference from the California rules where they gave you a 250,000 scuff per day limit. Here you're given 500,000 scuff above a baseline. It's basically they realized refineries are all set up differently. They're designed to put differing amounts of gases to your header, and so you have this kind of variability that's built into the rule. There's some different monitoring that's allowed and some exemptions based on if you have a water seal or not. And we talked about how some of those requirements for a water seal can get bypassed with an amp. You got the RCAs. Again, there's some exemptions for how to get out of doing RCAs. So everybody likes to know how can they get out of doing something. And one of the big things to think about is the timeline. If you have an event that you've exceeded your thresholds, you got 45 days to do both your root cause analysis and your corrective action analysis for both of them. It's not 45 days each. You have 45 days total. If you, you don't have to do anything within that 45 days to actually fix the problem. If you can, great. But if you can't, you just have to set a schedule for when you will be able to get that change installed. And basically you're trying to say, what caused the flaring? What could we do to prevent it in the future? And if we can do it and it's feasible, let's do it. Okay, so big ones for exemptions for the flow monitoring. Emergency flares, secondary flares, and flares designed to capture all normal operations. All in the definitions of each of these types of flares, they have the presence of a water seal. And that alternative monitoring is generally you're going to have to monitor the water seal drum for water level height and pressure in the header to basically know when did the pressure in the header exceed the back pressure of the water seal, so you can say that yes, you broke through the water. But they also said for these specific provisions, you can only bust through 4 times in 365 days. So if there are some facilities that are saying, yes, we're pretty confident we can meet that, we're not going to install the monitoring. But just understand that on the 5th pressure exceedance, you have 180 days to install your monitoring, which is for refineries and changes for that is not enough time. So most people, even though they feel pretty comfortable with the 4, they're putting in the monitoring anyway, just because they don't want to run the risk of coming under that time crunch. Especially if they're not going to be allowed to hot tap the flare and they would have to take a shutdown. Last thing you want to do is have that day, you got to go to the plant manager and say, hey, we're taking a shutdown in the next 180 days. Sorry. That's not a conversation I'd like to have. Okay, so one of the other things that the rule gave you was an operational limit for the amount of sulfur, or H2S, in the gas going to the flare. And this is kind of one of those tricky things that this concerned a lot of people. Because if everybody treated the flare basically as your wastewater treatment system. Whatever you had that you didn't want, you flush down the drain and it's gone. It goes, I went to the flare, it's gone. Well, now suddenly you can't flush everything down the drain. And once you get to 162 ppm, which for most refineries, that's not really an easy number to get through, you're having serious problems. We've seen this number drive a lot of facilities to flare gas recovery. So they weren't wanting to put in flare gas recovery for a volumetric basis to get that extra fuel back. They're putting it in because they know they can never meet the 162, so they're going to have to pull that gas out of the flare, treat it, and then they may end up flaring it anyway. So just kind of wrap your heads around that. Flare gas recovery is a very pricey alternative. So it does have a payback in that you will be getting some fuel back, but it is still a large capital investment. One of the things when you think about, here we have a concentration limit, and then we also have the 500 pounds RCA threshold. That's on an absolute basis. So it's just as soon as you've hit the 500 pounds, you're done, and it's just rolling. But when we're going to talk about the monitoring, you need to keep it separate in your head, because each concentration or pounds requirement has a different monitoring requirement, and how you think about them, you need to keep them separate in your mind, otherwise you're going to get them confused. No baseline. Yes, no baseline. 500 pounds you're at. And that's per flare. But if you have an interconnected flare system, that is a single flare, a single affected facility. So you may have 2 stacks, but you get 500 pounds for that system. It's not per stack. So it even gets it tighter. Okay, for the operational limit, to stay in compliance with that 162, you can put in an H2S analyzer. This has a span value of 300 ppm. You're going to need a QA/QC manual for Appendix B and F purposes, and there will be a compliance demonstration with that limit. For the RCA requirements, they gave you multiple options. They gave you the total reduced sulfur option, the H2S option, or the SO2 option. Each one is complicated in its own sense. So I still don't know whether or not giving us this variety helped people, because sometimes I think if people would have been given one option, then they would have known what to do and they would have done it. I think having all these multiple options made people have to go down a bunch of different paths before they could come back to their first idea. So I mean, it just has taken people a long time to get their heads wrapped around this one. For the TRS monitor, you need to do a span of approximately 1.1 to 1.3 times your maximum anticipated sulfur content. So what does that mean? That means you can no longer say, my analyzer was pegged out, I don't know what the concentration was. Because you have to have a monitor that can go all the way up. So if you have a acid gas flaring event and you say, I can see 90% H2S in my flare, well, you're going to be spanning to 100% H2S. Just start thinking about those calibration gases. Those are, the safety issues around those calibration cylinders are an absolute nightmare. I mean, you go into a refinery, you're wearing a monitor that's going to alarm at 5 ppm, and you're going to bring in a 50% cylinder. Who wants to change out that cylinder? Not me. So I mean, there's been a lot of discussion about this. Air Liquide is here. They have a booth. They actually have a neat little manifold system that they've designed that helps with clearing out some of those lines so you can do a bottle switch over more safely. So they have it out on their booth, so it's an interesting thing to go check out. Everybody wants to say, okay, well, can I use one monitor to measure for both the 162 and for the RCA threshold? The answer is yes, but there's always a but. If you use a TRS monitor, so you're measuring for the total reduced sulfur or total sulfur, which is mostly what you will be measuring, and you can't get a specific number for H2S, you now have to have a 162 ppm total sulfur limit, not an H2S limit. So if you had a lot of, say, mercaptans in your liner, carbonyl sulfide or something like that, you're pushed your facility with a tighter threshold. So most people are not comfortable with going with that. They want to get that pure H2S number so they can get as high of a limit as they can get. One of the things that you do, you say the 1.1 to 1.3 times the maximum, and you say, well, I don't want to get those high cylinder gases. Well, you're at least limited to 5,000 ppm of sulfur for that device. People always ask us, says, well, we don't really know what our maximum anticipated sulfur is. And it's basically, okay, where do you think you're going to be? Span your instrument there, and the day you peg that out, you're going to have to respan your instrument. So, I mean, it's going to be, potentially people are going to get pushed up as they have events and they see higher and higher sulfur concentrations. So that's where we see a lot of facilities saying, especially if you're in that high range of, like, say, 50% H2S, that's going to determine some technology things. And so you're going to be moving towards a technology that can go all the way to 100%. And there aren't a ton of options in that. For a total sulfur monitor, you're looking at most likely a Thermo Scientific Sola 2. Those ones can go up to 100% sulfur.
With dilution.
With dilution.
Total sulfur unit of light and tech or Thermo, they all have a basic, call it a snow line limit, an absolute limit of, depending upon the unit, 5 to 10,000 ppm. Right? If the sample contains more than that, you have to dilute it so the sample going to the detector does not contain that concentration.
Yeah, it has an internal 100-to-1 dilution.
But that's, you have to dilute that.
Mm-hmm.
So,
But the other ones can't go that high.
I'm sorry?
Like when we look at the ABBs and the Siemens, their total sulfur monitors, they're telling us that they're limited to 50%.
That's because of their approach.
Yeah.
You can do 100%
Yeah.
GC
Mm-hmm.
without dilution.
Yeah, the GCs, depending on detector. Yeah. Mm-hmm. Okay, and okay, I think that was everything. Okay, I already said that. Okay, so second option, you're going to go with the H2S option. You only want to measure H2S. You don't want to measure total sulfur. The ranges are the same, so you don't. That's all the same. The biggest difference is you're going to have to do a correlation sampling, and this threw up a lot of red flags for people. So a lot of people did not go with this. They went with because what you have to do is do an initial 10-day sampling event where you're going to get a sample and then determine what's the ratio of H2S to total sulfur. So, and you do that for 10 days, get yourself a correlation, and then you have to take a weekly sample. As long as that weekly sample is within the 95% confidence interval, you're good to go. Suddenly, if you get a sample that's out of that 95% confidence interval, you now have to do a new 10-day sampling event. So most people don't want to have to be sampling their flare that much. So they were like, they've gone away from this option just because they don't want the hassle of the sampling. Okay. The SO2 monitoring requirement. This one is one that they put in there. I think there's one refinery in the country that we've seen that can comply with this limit. The concept is say you have your fuel gas system for your refinery, and you have a boiler or a heater that's burning that gas, and it already has an SO2 SEMS on it. And then your flare only receives gas that is seen by it, is that same gas coming from the fuel gas network. So then they say you can use that SO2 SEMS on your boiler to back calculate what the sulfur concentration is in your fuel gas, and then calculate how much sulfur went to your flare. So if you have any other connections to your flare other than that one from the fuel gas network, you can't use this option. And that's where pretty much everybody said, I don't even need to think about it. So, so it's used very infrequently.
Herman, I'll
Okay.
ask a question on that. With the exception of like PSCs for emergency relief, those can still be connected?
No.
Or the only things that can go to that flare header is what goes to the heater or boiler in that.
Yes, because this is the TRS, the RCA threshold, which includes process upset gas. So you have to. So if you have a PSV that's going to put process upset gas, it still needs to be monitored under this. But for this, the thing I was talking about here with the three options.
So 500 pounds?
Yes.
Okay, so 500 pounds includes the upset gas, and that would be, okay, thanks.
Yep. Okay, so the big question is, what's the optimal configuration? We've talked about using a single analyzer, because you could use a single H2S analyzer or a single total sulfur analyzer. Do you want to have two analyzers? Do you have one high scale, one low scale, one H2S, one total sulfur? There's lots of options, and people have gone in a bunch of different directions. We haven't, it's one of those things you wonder if everybody's going to come in on the same answer. The answer is definitely no. We see people going with all different types of technologies. The only time we see a relatively consistent path is for people that already had a GC on their flare for complying with NSPS-J. So they already had an H2S, they could measure H2S on their flare system at the span to 300 ppm, and then they said, okay, well, we need to just take care of that. They would add like a SOLA 2 to go for the total sulfur monitoring. That's the only real consistency we've seen out of folks. Exemptions. We love exemptions. We always want to get a way out. When they wrote the rule, they were nice enough to say, well, basically, if there's no way you can have sulfur in that stream, you don't have to monitor it. So, I mean, thank you. We don't like to put in analyzers for no reason. So, I mean, you don't have to monitor pilot gas. You can also, if the gas is coming, or especially a lot of times you'll see from like loading operations, if you're loading a commercial grade product that has a sulfur specification, and you know that it's going to be less than the 30 ppm of sulfur in the 30 ppm is in the liquid product. So it's as long as it's less than 30 ppm in the product, then they're going to say the vapors are going to have so little sulfur in it that it's inherently low in sulfur. The other ones are if that process is intolerant to sulfur. If sulfur gets into that unit is going to get fouled up and it's going to be shut down. So, basically, you're not letting sulfur in there. If you have flares that are only tied to those units, you get out of monitoring. We see that the most with like the HF alkeys. A lot of times people have segregated their HF alky to have its own flare. Boom, they don't need to put in the monitoring. If you have a stream that is not in one of these nice little caveats, you can do sampling to show that that stream is inherently low in sulfur, but you got to meet less than 5 ppm H2S in those samples, and I believe it's a 14-day sampling event. So I mean, it's a lot of sampling. You have to submit an application to the EPA. I believe it gets published in the Federal Register, and then you're granted it. So not the easiest of processes. The other exemptions for RCAs or for the monitoring is emergency flares. Again, it's if you have a physical barrier to the gas going to the flare all the time, they say you don't have to have continuous monitoring on it. In those cases, when you do bust through your water seal and go to the flare, you can use engineering calculations to determine how much SO2 you put out. Okay, flare management plan. A couple of things that you need to have in this plan, and this is just a list of some of the parts. This is the part where you say, what do I have? One of the biggest things is this listing of, and it should say all process units and ancillary equipment that are connected to the flare. And the nice one is they've defined an ancillary equipment as a PSV. So that pretty much gets in all your PSVs, which is nice. So we've done a lot of projects where we go into a facility and we say, please give us every single one of your PNIDs. We're going to look through them and identify all the connections to the flare. It's a fun process. I highly recommend it for everybody. It's a good way to test your eyesight. That's all I gotta say. But so you're going to get all this information. Hopefully it's readily available. Some of this stuff, it takes a little more digging because, again, the flare was the flare. It was that safety device that's sitting out maybe half a mile from the facility. Nobody thinks about it. Where is the paperwork for it? Nobody's done anything. We've been at sites and we're digging through the old stuff and pulling out, you know, design specs from the 70s and saying, is this still right? We don't know because it's just not documented well. The flare management plan asks for a few drawings. One of the drawings that is the P&ID type drawing is the flare tip drawing. They've requested this drawing. We don't know what they're going to do with all these drawings. We can only imagine. We always say it's going to be some poor intern's job one summer he's going to walk into a room and there's going to be a stack of 500 flare management plans, and they're going to say, find the flare tip drawing and get all this information off of it. And then we'll see what they do with it. We don't know. But this is the only one that was specifically called out. Yeah. With the other drawings, they only ask for PFDs, process flow diagrams. So this is one where we say, please do not submit P&IDs to the EPA. You're pretty much going to be pushed into calling that CBI, doing 2 versions of your report. It's a big nightmare. So we call these our cartoon drawings. We like to just say, you know, they ask for a simplified one to show the process units that are going to the flare. This is actually a pretty complicated one where they had 3 interconnected flares with flare gas recovery. So it's just kind of showing what units are going to go to which flare and how this is set up. The other PFD that they asked for is more specifically tied around the flare system itself. Again, it's going to be showing the different types of lines, the assist lines, the pilot gas, and it wants to see where your flow monitors are, where your analyzers are, water seals, knockout drums, etc. Okay, for these flares that were all defined as having water seals, you're also going to need to give some detail on those water seals so that you're going to document, you know, where is that liquid range supposed to be, you know, how much back pressure are you putting on the system? Are you using one of the monitoring alternatives instead of the flow and the sulfur monitoring? If you have flare gas recovery, you're going to have to give them some more information on your system, number and capacity of the compressors. One of the things that isn't always caught is, or isn't always on a system that's been there for a while, is a means to monitor the amount of, how much gas is being recovered by those compressors. You know, some of the older systems, they don't have a dedicated flow meter for that, so that's another place where you may be adding a flow meter. One of the things you have to say is, what is the maximum amount of time required to start up the second? Like if you have multiple compressors, but you have one that's running all the time, and then you have another one that'll kick on when you're having a higher flaring day, is what's the time it takes you to get that secondary flare or secondary compressor running? You know, we talk to people and they say, oh, you know, we can turn that on within 5 minutes. And we're like, okay. Is that every single time? And I'm like, well, most times. And we're like, okay, so if it didn't start the first time, how long would it take you then to get it started? And so it's kind of understanding that you're going to be documenting this time, which is going to be used for determining, you know, some of your get out of jail free cards. How much time do you want to give yourself for that time to start that secondary compressor? We saw it from it was Shell's, I believe it was Shell's consent decree. They had in there they were given an hour to get that secondary compressor started up. So part of us thinks that, you know, why should anybody ask for less? The EPA has already said that it's acceptable for one facility to have an hour in between the primary and secondary, so why would you say less? But of course, it's always nice to have some sort of justification around that time. You just don't want to say, oh yeah, we threw out an hour. You want to be able to say, you know, there are some extenuating circumstances where that's how much time it's likely to take. You also need to include procedures for minimizing flaring during this compressor staging, or compressor outages. You know, if you've got to take your compressors down for maintenance, or if you only have one compressor, it's going to need maintenance every so often. You're going to have to take it out of service. How are you going to minimize flaring during that time? Okay, minimization assessment. This is part of the process that really takes a good bit of time. The FMP, or the rule, was sort of specific, but not very specific on how this assessment is supposed to be done. They listed these items here for things that need to be assessed. One is at source reduction. You need to look at, you've already said you have to provide a list of all the connections. Now you need to figure out, did you look at all those connections to see if you can minimize the contribution from that connection? You have to, while you don't have to install flare gas recovery, you have to assess whether or not it is feasible to put in. So, you know, if you were right on that edge, you may get pushed into needing to install FGR, because if you can say, do the analysis and say, yeah, it's feasible, people are pretty much going to say, so if it's feasible, why don't you do it? So, you know, that is something you're going to have to consider. Other people say, well, my facility's fuel gas long. We always are producing more gas than we can use. You know, we can't, why should we put in flare gas recovery if we can't use the gas? Because we just have too much gas. And the rule writers decided to say, nah, you can't pull that one on us. You have to also consider installing cogen with your FGR to burn that gas and create electricity with your excess gas. So you have to assess it. Hopefully, if you don't want to spend a lot of money, it's not feasible. And then you have to also, one of the things is you have to minimize your sweep and purge gas flows. We think that this was included because these are the flows that are always going to your flare system all the time. So while they are small flows, they're constant flows. So you need to make sure that those are set down to their minimums. But I think minimums, especially on some of your purges, as we talked about earlier, you may start having those minimum purges set for maybe some combustion parameter reasons, not just flare tip design. When you're doing this rationale for your minimization assessment, you're told to consider these things. Usually cost is the one that'll get you out of a lot of things, especially flare gas recovery. You know, a facility says, well, we have excess gas, but it's not a lot. And sure enough, you look with their flow meter and you're like, well, yeah, it's a payback period of 20 years. well, yeah, you're probably not going to install that flare gas recovery unit. The one thing that I thought was interesting, well, that I've never seen, is what does the EPA say is cost effective? They pretty much don't say what is cost effective. And people say, so how do we know we can rule something out? Because, you know, they're saying, well, what do they care if it takes us 10 years to get our money back? And kind of the rationale that we've been using around that is, what's the cost effectiveness you use for all your other projects? If you have where you can't do another project at the facility unless it can pay back in, say, 18 months, and that's just the rule, nobody gets a project, you know, 2 years, you would, if it's more than 2 years, you would never do it. Use that same rationale for your cost effectiveness for your flare gas recovery unit. At least there's then a basis around that rationale. Okay, so it's overall goal is to minimize flaring. It's kind of bringing down that quantity of gas that's being flared. One of the, you know, and so if you think about it, then that's, as you're minimizing your flaring, you're also bringing yourself down to that high turn down case that we've been talking about is so hard to control for. So we see that there's kind of things that are going to be driving the need for a lot more of these control systems around your flare because of the reduction in gases going to your flare. When you're doing your minimization, you always want to start with, you know, identify all the connections and try to do kind of a, you want to kind of prioritize the things you're looking at. Because, I mean, if you don't want to look at, you know, a single pump seal and, you know, say, well, yeah, well, we're going to reduce flaring here. Well, that's not really getting the most bang for your buck. You want to look for some of the higher flows that are going to your flare and try to prioritize those. One thing to think about, though, when you're minimizing for your minimization assessment, go after your high H2S contributions first. Remember, you have 162 concentration limit. If you go in and say, oh, I got this great big sweet flow, I can redirect this here, and you look at all this gas we're not putting to the flare. And suddenly your sulfur concentrations in your flare just went up because you took out all that volume of low sulfur gas. Suddenly you're in a world of hurt because now you've got to get all the sulfur out too. So go after sulfur first, then go after flow. And you can hopefully save yourself a headache of creating more problems for yourself. Things to think about with your redirected streams, especially high BTU streams. You know, those are the nice streams that we want. Those can maybe go to fuel gas. Or if there's enough content, maybe they can go to another unit to maybe, if you got a lot of butanes, you can maybe pull out some of those butanes and get a saleable product. I mean, that's kind of the greatest thing, is when you can find a new source of product. One thing we did when we started doing these was we really thought about, how do you document that you've done your minimization assessment? I mean, it's one thing if somebody comes in and says, show me how you minimized your flaring. I mean, if you say, yeah, we looked at stuff, I mean, that's not giving anybody a warm and fuzzy that you actually did anything. So when we were asked to help people do this, we created this, this tool. I don't know if anybody's in the B1 world, but Sage has our DACT for a B1 accounting. We created the DMAT, the Documentation Minimization Analysis tool. It's basically a way to systematically list out all your connections to the flare with the rationale of why you're using them. You know, dots on H2S concentration for identifying those ones that'll come out, need to come out sooner, and you know, potentially flow rates associated with those things. Flare mapping. You don't have to have this drawing, but for a facility, if I walk in and they hand me this drawing, I am extremely happy, because that tells me that they have already thought through the process of what is going to their flare. This is, don't try reading this one, it's actually all in Italian, we got to do a flare minimization study for an ethylene cracker in Italy, which was really cool. But they had this type of drawing where it doesn't show a ton of detail around the actual connection, but at least you know where all these connections are coming from, what drawing to go look at. And I mean, it even includes things like sweep gas additions, and I believe there's an analyzer shelter on here too. So I mean, it just kind of shows you that they've thought about what is everything that is going to their flare. It also gives you some, when you do it spatially like this, it also gives you some ideas of saying, well, instead of having just one flow meter, maybe I put a couple of flow meters on some of these branches so that if I have an RCA event and I need to go find out where did that flow come from that triggered 500,000 scuff per hour or scuff per day, you can say, okay, well, this flow meter is showing all the flow. At least I've reduced it to a certain amount of connections. I'm not searching the entire system to try to figure out where it came from. This is just a screenshot of the DMAT, so you can just kind of see that, you know, it's a connection by connection, basically valve by valve analysis of the system. Minimization, again, one of the big things, and this is more for people who are really trying to avoid installing flare gas recovery, especially for high H2S. A lot of times people aren't purposely putting this high H2S gas. A lot of times the source is leakage. You know, PSVs leak. That's just what they do. I mean, that's why they have leak factors. Also, so using, going around and trying to identify, especially on high H2S valves, if they're leaking or not, can be incredibly valuable. This is the VPAC 2. It's an acoustic device made by Mistras. Basically, it uses acoustics. You mount the two probes on the valve itself, and it basically listens, and it can hear that turbulent flow of gas, you know, getting by that valve. And even if with the VPAC 2, if you input, you know, valve size, valve type, pressure drop across the valve, and then what it hears, it will actually output a pounds per hour number to you. So you can actually have a way to maybe quantify how much gas is going by that valve. It does have some issues, so it's nothing's ever perfect. If you're in a noisy unit, you know, you got some compressors by, this thing is highly susceptible to ambient noise. So I mean, and then it's more looking at, you know, rate of change. You know, are you looking at a valve and it's always reading that you have some flow, but you don't think it's really leaking? You know, check it repeatedly over time. Is it still always about that same number, or is it maybe increasing to maybe show that a leak is actually developing? So it's a tool, but it's no magic bullet. Baseline flow. You have to set a baseline in the FMP. They were nice enough to provide almost zero guidance on how to calculate your baseline. All they said is it has to be reasonable. So we'll decide what's well, they'll decide what's reasonable. We'll submit what we submit, and they'll say yes or no. So it's looking at your data from your flow meter. So this is one of those things as if your facility didn't have a flow meter, it becomes more and more difficult to try to assess your baseline. You don't have to include the pilot and purge gas unless the purge gas, or unless these are not, if they're variable. If they're highly variable, then you do have to include them, but if they're stable, you don't. You can use alternative baselines. If you have an operating scenario where you're normally at, but then say you've got to do a regen on a catalyst or something like that, and that happens every 6 months, and you know you're going to be purging a lot of gas through that vessel to get it ready. Well, then you say, okay, it's going to trip my RCA threshold. Well, I don't need to do an RCA to know that we were doing a regen. So the rule allows you to set an alternative baseline for that activity so that you don't have to do an RCA needlessly. We recommend greater than 6 months of data, just because a lot of facilities have seasonal variation to their flow. You know, in the summertime, things heat up, things are producing a little bit more off gas, tend to have a little bit more flaring, and you'd rather have those periods of higher normal flaring in your baseline than doing it, say, in the winter and having a much lower baseline that you have to deal with. Okay, here's some data from a refinery. So for setting their baseline, we were looking at the data and trying to say where we wanted that baseline. So we took the data, and this was, you know, they had to get a baseline set, so but they didn't have documented through time kind of what these different spikes were. So we are kind of going with this, we don't have a reason why to include or exclude these peaks. You know, to be reasonable, you know, including this peak here in your baseline calculation, I don't know if that's, to me, that's not reasonable. I think that's a clear emergency event, which is not part of normal load. So what we said was, okay, let's calculate the average plus 2 standard deviations and say if you're over that range, that's most likely a malfunction event, something that shouldn't be included in your baseline. So then taking that reduced data set, then we calculate the average of the reduced data set, and we get around 3,000 scuff per hour. And so you still have some variation in here. And one of the things that we thought about was, you know, with a facility as large as a refinery, there is some level of maintenance going on probably every single day. Somebody's doing maintenance on a pump or a compressor or something. So trying to take out all these little maintenance events, you know, once it's happening almost every day, it's pretty much part of normal routine venting. So we said, don't take out those small minor maintenance events. Sure, a whole plant shutdown, yeah, that's probably shouldn't be included in your baseline. But some of those smaller maintenance events include just because you don't want to have to deal with too many root cause analyses. So then we also were saying, okay, is there another way to look at the data to kind of say whether or not that 3,000 scuff per hour number was a good number? So then we took the data and we kind of made a histogram of it, kind of just saying, for the different flow ranges, how many data points did we have in each one of those flow ranges to see, you know, what's more routine. And so, you know, obviously you got here, that's probably, you know, your base purge case. You know, here you're probably getting into some of your minor maintenance events, you know, kind of just day-to-day kind of stuff. And then you had a pretty big drop here, which correlated to about that 3,000 scuff per hour lane. So then we started to feel more comfortable saying that this number that we, you know, coming up and using a number of 3,000 scuff per hour is probably reasonable. But when we saw the data, it had relatively large periods of consistent flow. So we had another flare that their flow rate was definitely not consistent. So we did the same analysis on it, took out the outliers, and it's still highly variable. So we're looking at that average, and we're looking at 2.2 million scuff per day. But you still, you know, how comfortable are we with that number? Put it on the histogram, suddenly you're looking like, okay, this is not, again, something that's telling us a clear picture. You know, you definitely see that big drop between, you know, right around 2 million scuff per day. But what about these events out at 3 million scuff per day? You know, are those, you know, valid things to keep in your baseline? And you know, when you're looking at the quantity of data, I mean, if something's happening 66% of the time, you can be pretty sure that, yeah, that's more routine. You know, when you're getting into 89%, you know, it's maybe telling you that you can come out to that 3 million scuff per day. But it's definitely being able to document your rationale. Do you have certain streams that are going to be going to the flare more frequently? Maybe you could say, well, yeah, we could have an alternative baseline for 50 different things. It's like, well, do you really want to have 50 baselines? That gets a little confusing to try to say which one am I on today, and what are we gonna say? So, you know, maybe you want to have a slightly higher baseline to include more of those events to have fewer alternatives when you get to have so many alternatives. Yeah. Yeah.
Back to your earlier comment?
Yes, you can have as many baselines as you want.
So you could potentially have a March to August or whatever.
Yeah, it's just making it a reporting nightmare in that you have to say, okay, I have a flow rate. What baseline am I at? Did I exceed it? Do I need to do a root cause analysis? And so you're going to have an accounting nightmare. Okay, procedures. The planned startup and shutdown of units. Basically, they said if you create written documentation of your procedure, startup and shutdown procedures, and those procedures take into account minimization of flow to the flare, if you're following your procedure and you exceed your RCA threshold, you do not need to do an RCA. Because if you did an RCA, what would it tell you? I was doing a startup, or I was shutting down. So you don't have to do that. But if you don't follow your procedure, then yes, you would still have to do a root cause analysis. That root cause analysis would then be, why didn't we follow the procedure? So I mean, there's going to be some things you're going to have to do to make sure that people, and also those plans need to be written. They're very specific about that. You need to understand, how do you minimize flaring during fuel gas imbalance? Some facilities we talk to, they say, oh yeah, we'll cut rates. You know, we know that this unit's producing a lot of off gas. We start flaring, yeah, we'll call them up and see if they can cut rates a little bit. Other ones, no, we're not cutting rates. You know, it just kind of depends on where you're at. But you need to be able to say what you're going to do to try to not flare during those periods. You know, do you have a means to shut off your purchase gas quickly? You know, you don't want to be buying gas when you're fuel gas long. So, you know, it's how do you make sure that you're not purchasing extra gas? And same for that, the flare gas recovery outages is how do you minimize that gas? The QA/QC manual required under Appendix B and Appendix F. It's just a good place for you to document, you know, how are you doing your daily drifts? What are your concentration ranges you're using for your spans? Your cylinder gas audit requirements, and then whether or not you're using the relative or doing a RATA, or if you're using the alternative RATA method. Record keeping, obviously you need to keep a copy of the FMP. If you're using any exemptions for anything, you need to keep records of that. And then we have here some of the data points that you need for when you're doing an RCA. Okay, 264 days and counting. Everybody ready? Hope so.
Did you change that from yesterday?
I think so. It is rapidly approaching. And, you know, one of the things that we've been telling people for years that you need to do something. But, you know, we've really been pushing lately just because the lead times for instrumentation right now is very long. I don't know if anybody's tried to buy an analyzer lately, but those lead times are a little bit longer now because there's a lot of people in line to get them. So, so if you have any other projects that don't maybe need to be done right away, maybe wait till after November to let all these other orders clear out before you you do your orders. Yeah, pretty much everybody's into the November 11th time frame at this point. Okay, any questions? Okay, I think we're going to move on to Tom and Quad O.
So I know you guys are just dying for the 3 o'clock break. But if we break now, we won't get through all of our prepared materials. So thanks, Herman, for putting me right before the break.
It's what I do, man. Okay.
So let me just start off with some questions for you. Oh, yeah. So I was here this morning when we did introductions. Who's in or serves the refinery sector? Raise your hand. All right, we got a couple. All right, good. So obviously the things that we've been talking about today a lot of the regulations are around the refinery sector. Petrochemical sector serves or in. Okay. Upstream, midstream. I saw, okay, good. So Quad O might be of some interest today. I have one more slide that I want to show. And let me see if I can do this quickly. So most of my career, 25 years, have been in Houston. And if you're familiar with the ship channel, that's a stretch of a large concentration of plants right across the ship channel. And hold on. Let's see if I'm going to lock this thing up. And let me go back. Where am I? Can't. There we go. Thank you, Herman. So it's worth the time. So give me just a second. So last week I was up in Kansas City doing a conference for AWMA, and I just assumed folks had seen this picture, but it's not in my current slide deck. It's just something I recently added. So let's see if I can get it up here. All right. So who has seen this picture before? All right, good. So about half the room. So I was just going to have some fun with it because we try to have as much fun as we have in this room. So, I'll be talking about this in just a minute. So the White House and the EPA just announced, mid-January, late January, about new controls for methane emissions. They are probably most likely looking at Quad O to implement a lot of those regulations. And if you haven't heard about all the noise around flaring in the oil and gas sector, this is a NOAA picture, satellite at night. And if you haven't seen this before, so you get Chicago, and I'm a Midwestern boy originally, so I'm familiar with the Great Lakes. You get Minneapolis, and then literally out in the middle, I have not traveled to North and South Dakota, two states I have not been to and not on my done map. But so guess what all this is out in the middle of the Balkan oil patch? Flares, associated gas flaring. So we'll talk a little bit about that today. Here's a little bit closer. So now a little bit more in my backyard I'm a lot more familiar with. So here's Houston, here's 6th Street where all y'all were lit up last night, right in there. So San Antonio, and then you get this patch right in here. And so if you guys, of course, have heard of Eagleford Shell, same issue. There are some towns in here. It's not near as sparsely populated as here. But as you can see, and you drive out there, I was oil and gas upstream for 3 years before returning to Sage in January of 2014. And I spent quite a bit of time out in the Eagleford. Truly got to see what an oil boom looks like. And I hope, quite honestly, that it continues with the oil prices the way they are, but they're on their way back up. We'll see if that lasts. So let's get into today's material. All right, Herman, am I doing this one right? Okay, so with that said, I'm going to cover Quad O. And it mainly affects the oil and gas sector, but why does it get me excited? I think it really gives you some indication of where the industry is going, just like JA. I mean, let's get real for just a minute. So I mentioned the ship channel, and about 2/3 of my career has been in operations. And I honestly can remember times when I've gone into the control room and I've said, okay, guys, hey, your flare right now is about 30 feet high. What's going on? And literally, I'm not joking, this is not an exaggeration. They go, well, it's not me. And this plant was split up into 4 areas, and you go around to each of the 4 operators on the board. Hey, anything going on? What's going on with the flare? I don't know. Everything's good here, not me. And you make your way all the way around the room, and you're like, okay, guys, what's going on? And until the DMAT tool or things like it that we're familiar with B1, if you've been part of that in the environmental world, most of the time the operators never knew what valves were open to the flare because they're not a control valve. They've got a knockout pot that was giving them problems, and they open up the manual valve to the flare, and 3 days later it's still open. And so now I think, you know, it's amazing to me that from this morning's talk, Herman and Rashab talked about that first flare alert was in 2000, and here we are in 2015 still talking about oversteaming flares, and it's a real mind change for me. I can drive up and down the ship channel and see tens, if not hundreds of flares where there are no flames present. But now you have to ask yourself today, do they have flare gas recovery? Do they have a water seal? Are they really not using their flare? Or potentially are they oversteaming it? And of course, not your all's flare, but maybe your neighbor's flare has a steam. I have seen one recently where the steam, not the flame, had to have been 20 feet high. I mean, there was just so much steam coming out that flare. It was the poster child for probably an oversteam flare, and I just couldn't take a picture of it at the time. I wish I could have. I was inside the plant at the time. So anyway, just a real mindset. Things that we haven't thought about for decades are now back in the forefront. So let's talk about Quad-O. Again, ask questions as we go, and Kelsey, 3 o'clock, will you wave at me and make sure we hit the hard break? And then we'll come back and finish up whatever I don't cover here. So Quad-O covers the oil and gas production, transmission, and distribution segment of the oil and gas industry. So the downstream folks have been highly regulated for years. This is really a new rule that came out like everything today from a lawsuit in 2009 that made the EPA address emissions from the oil and gas midstream and upstream businesses. So I'm going to go over the history and timeline. I'm going to talk about brand new rule revisions that just hit December 31st. That had to be a deadline that somebody inside the EPA had to meet because they literally posted it on December 19th and it was published on the 31st. We're going to talk about how the rule is organized with the applicable sites and affected equipment. And then I really do want to spend a few minutes on Colorado. There's talks tomorrow that talk about Colorado, so I'm going to go through those pretty quickly in case you don't catch all of the Colorado talks tomorrow during presentation day. But I think Colorado is ahead of the game from probably where Quad-O is going to go next. So I mentioned this was an industry segment that was fairly, not from a oil and gas commission standpoint, the drilling and completions work had always been highly regulated, but from your environmental state agencies, primarily overlooked. A lot of the oil and gas industry had been pretty much overlooked from a regulatory standpoint. So Quad-O completely changed that. The lawsuit, which I already mentioned, was one of the drivers that led to this rule change, and we've gone through now 2 rule changes in Quad-O that I'll go over. We mentioned this early on other NSPS rules. Just remember, for folks that aren't full-time in the environmental business, you have to be a new source. You have to be a new source by construction or a modification or reconstruction to be affected by the rule. So just keep that in the back of your mind. It's different than a MAC rule that we've been talking about today some, and one we're going to talk about later today, MAC CC, where there's kind of a hammer and it affects all the facilities of that type. Okay, this is our timeline. So back to 2009 with the lawsuit to when the rule was published and promulgated the first time around, and then we had stage 1 revisions primarily to address storage tank issues, and now stage 2 revisions that just came out the end of last year. And then this is kind of a mention to what I've already talked about, the EPA talking about new proposed rules later this year. So let's just keep on going. So I want to touch on the rule changes because I was thinking a lot of the folks in here may be affected by these rules and just really hasn't had time to dig deep into the rules. Most of the rule changes were clarifications, which were very helpful to the industry. But there are at least one thing that I'd like to talk about today that I think is more confusing now than it was before. So the first thing is, if you guys have worked in the Title V world, deviation report world, there was a lot of discussion about, for small oil and gas companies, designating a responsible official could be the president of the company, and do you really want the president of the company signing off on an environmental report that's due once a year? So in response to that, they gave some leeways and really got away from the term RO, or responsible official. Now it's certifying official. The main message here is if you're a small company, less than 250 people, you can designate who you want to sign your reports. Otherwise, if you're a larger company, 250, it's pretty much the same. You're going to be asking your vice president of operations, one of your senior HSE officials, to sign the reports. And for the lawyers in the room, or wannabe lawyers, there was some affirmative defense written into the rule for the first time around, and that's been stripped out. So well completions. Folks that aren't in the rule every day think that these rules apply to flowback hydraulic fracturing of all wells. Quad O today applies to natural gas wells. And so when 99% of the country is going after oil right now, and most of the development of oil, you would say, okay, this doesn't apply. That really surprises people. So just keep in mind, the rule was originally written when everything was gas, and the EPA was really addressing gas wells. So as of today, gas wells are required to have controlled emissions during flowback. One of the changes in the rule, this was very helpful, when you start a flowback, there's a short period of time, I'm talking about a natural gas well, where you're mostly getting water. You just pumped all the fluids down, mainly water, into the hole, and you're flowing that back, and you're going to get a lot of water. This, depending on the type of well it is, could last a few minutes to a few hours. And when you're pumping back water, there's no way to separate the gas from the water or the hydrocarbons and get a separator to work. So the EPA recognized and agreed with this fact and said during the initial flowback stage, you're allowed to store liquids in temporary frac tanks, and you're not required to capture the gases. Okay, so you don't have to control your emissions during this stage. But in some of your high pressure wells that are being drilled out there today, that's going to be a very short period of time. You're quickly going to go back into your separator flowback stage. I like to use a rule of thumb between 15 and 30 pounds of pressure coming out of the hole. You're going to be able to run a separator. It's going to separate the liquid from the gas. And it is at that time you are now in this flowback stage, and that's when you have to have your gas routed to, from your separator, routed to the flow line, all right? And you've got to start recovering your gas and conveying it to a flow line, sales line, or a combustion device. So that was very helpful change, part of the rule. Okay, storage tank controls, I'm going to go into those a little bit deeper in just a minute. But they did clarify rules. The big trigger on storage tank controls is if you're greater than 6 tons per year. And so they basically allowed some clarifications around vapor recovery units. If you use a small compressor to get your flash gas off of the tanks and compress it into your sales line, they want to give you credit for that and basically not have it go into your calculation for the 6 tons per year. So the first change around storage tanks here was, again, helpful to industry to just clarify that if I'm using a VRU and I'm less than 6 tons per year, I am not an affected facility, or the storage tank is an affected facility. Thief hatch requirements, one of the banes of the industry. That's basically a gauging hatch on top of the storage tank. They either get left open by your water hauler, oil hauler, or they're not well maintained. And so there are requirements around thief hatches, mainly to just say, hey, there's other mechanisms that you can have in thief hatches to keep it properly seated, and the EPA didn't want to be quite so restrictive. I'll come back to this in a minute, but just to say this is, I think, the confusing part of the new rule. What it has to do with removing tanks from service and bringing those tanks back into service, which happens a lot in the industry. As wells deplete, you may shut in the well for a period of time. You don't have to comply with the rule if you empty that tank and degas it. Completely makes sense. But when you restart the well and you may refrac it, you've got to be ready to bring those tanks back into service and be in compliance pretty much on day one. So they added a lot more language around removing and adding tanks back into service, which I'll talk about more in a little bit. Reciprocating compressors. I think a vast majority of the compressors in the field are reciprocating, and the control requirement is mainly rod packing replacements, maintenance. But they also said that if you do route your rod packing chamber to a control device, that's okay. So that wasn't in the rule, and there must be some folks out there that control their emissions that way, and the EPA says that's fine. Equipment leaks. I have not done any work on the North Slope, so I can't speak to that too much, nor just revising equipment leaks. These are more clarifications. I would call those technical corrections that doesn't allow you to suck in more rules and provisions of the rules depending if you operate in Alaska. So that's the changes. I wanted to spend a minute on those. And but let's dive just a little bit deeper into the rule, and since this is a Flare Essentials class, I'm trying to tailor my comments to the control device requirements. So the first thing you need to know with this rule is where in the oil and gas segment are you operating? Are you in the natural gas production sites, crude oil production sites, gathering and boosting natural gas, compression, transmission, underground storage? If you are operating in those segments of the industry, you could be affected by this rule. So a nice picture, there's 3 or 4 different types of pictures out there. In the Oil and Gas Essentials class that I'm a part of on Thursday, we actually break down each one of these segments. The blue is not affected by this rule, and pretty much when you get to the distribution system to customers, that's pretty much right in here where the rule kind of ends. So it is comprehensive. It covers a lot of the distribution all the way up to the gas plants, to the power plants, but once you get into the refinery and downstream from there, it doesn't apply. So again, I'm not going to go into that much detail about all the different segments. So I mentioned gas wells. These are the applicable, there should be affected facilities. Gas wells, compressors, pneumatic controllers. That's natural gas driven pneumatic controllers. When you operate these controllers on an oil and gas site, you use the natural gas or field gas to operate the controllers. So you're going to have methane emissions from those controllers. That's an affected facility as part of the rule. Storage tank controls, which I'm going to spend some time on. Fugitive components. Fugitive components primarily from a federal level are pretty much unregulated at the upstream prior to the natural gas plants part of the field. This affects mainly natural gas plants, fractionation plants. I'm going to talk about the control devices. We're going to spend some time together on that. And then there is a part of the rule that talks about natural gas sweeteners. That's CO2 and sulfur removal. I had this table on my wall for about a year because depending on which rule you were working in, it helped you keep things straight in your head. I will just give you one example. If you were working Quad O, which this table is, and you have a reciprocating compressor at a well site that's literally just lifting the gas from that production well and getting it into the sales line, that reciprocating compressor over here would not be an affected facility. In subpart W, if you guys had any greenhouse gas reporting requirements, that little compressor that you have, maybe a few hundred horsepower, would be covered by subpart W. So crazy. You got to keep it straight. You got to know what rule you're talking about. And in this case, reciprocating compressors that are in gathering and boosting stations are covered by the rule. Why all these X's here for control devices, which we're going to be talking about? It's mainly because if you have storage tanks anywhere in the transmission production segment, you are covered by the rule potentially if you're greater than 6 tons per year, which we'll go into. So I tell people, put a tab on this slide, and it really helps you keep the rule straight. Okay, turning, what time is it? 7 minutes. All right. We'll get through compressors, and then we'll take a break and let you guys get to the break. So let's touch on compressors. It was going to be just to talk about control device requirements for centrifugal compressors, but EPA just added reciprocating compressors if you use a combustion or a control device to control emissions from reciprocating compressor rod packing boxes. So, and then yesterday I was reminded, and we'll get into this, it's centrifugal compressors with wet seals. If you are a mechanical engineer or have a lot of mechanical background, there are centrifugal compressors out there with dry seals that don't use any fluid to maintain the seals. Those are not affected by the rules. So let's get into that, and then we'll take a break. So centrifugal compressors, I don't see a lot of those. I'm the natural gas boosting, true boosting stations that are along the transmission line, moving the gas from the field to the natural gas processing plants. You're going to see maybe some centrifugal compressors there. You're going to see them in natural gas fractionation plants. Quite frankly, I think there's tens if hundreds of centrifugal compressors, not that many with wet seals anymore. I feel like there's hundreds or thousands of reciprocating compressors out there in the marketplace. So just a nice depiction of the difference. And we're talking about emissions that come off of the mechanical section of the compressor, not out the stack where you have your combustion emissions. So compressors, another fun thing that we had to try to educate, especially vendors on, if we have any rental companies that you deal with. For years under the NSPS rules for Quad J, Quad I, NESHAP MAC Z, 4Z, the engine rules or RICE-MAC rules, a lot of acronyms. We always have been tracking when was that engine built. And so now all of a sudden we're asking our vendors and suppliers, when was that compressor built? And they really looked at you and kind of scratched their head, because that's just something that they haven't been tracking until this rule. But since it is a compressor rule and not an engine rule, you do want to know if your compressor was manufactured, constructed, modified, or reconstructed after August 23rd of 2011. So I like to spend a minute on this slide and tell you compressors and their engines are mated and paired up in the factory, and they come out on a skid and everything's good and it's sized properly and your engineers have done their thing and they got the right thing out there. And then a year and a half later, either through decline of the well or the engine dies, you bring out just a new portion of the skid and just replace the engine. So now over time you have these engine compressor skids that don't have the same or nearly the same manufacture date, and you'd be surprised how many skids are out there that the dates you get from your vendor supplier are for the engine and not the compressor. So a big catch there if you're working in that to make sure you find out the manufacturer date, because that's going to tell you whether you're an affected facility or not. I just like this picture. So we're talking about a wet seal and a centrifugal compressor, and these are just some of your control options. You can go to a flare, which we've been talking about all day. You can recompress it and use it as a fuel. You can compress it into the sales line. Maybe you can use it in a fired source that's on your facility. So just some different options that are all allowed under the rule. What is required? You got to have a 95% emission VOC, volatile organic compound emission reduction, or 20 ppm TOC in the exhaust. And if you use a combustion device, you've got to maintain a minimum temperature. 95% VOC reduction, we've been talking about flare DRE today. That's typically 98 or 99 if you're not over steaming your flares. Generally in Quad O, the requirements were a little less stringent, and pretty much across the board we're going to see 95% in most of the control requirements. If you use a flare on your compressor, which is not super common, it's your standard 60.18 type requirements for your flare. So we've been going over all those today. I think I'll just keep on going. All right, I've got 2:59. Let's let you guys get to refreshments. We are going to pick it up sharply at 3:30, and it'll be the final push to get to the end of the day. We'll see you in 30 minutes. Thanks, everybody. So let me, it's getting late. You guys will want to push out the door. I do want to, I know we've talked about it a couple times, but part of the 4C conference is supporting all the folks that are here, and we appreciate everyone that's either a sponsor, a presenter, or covers some of the presentation booth materials. So tonight, if you've never attended, but if you have, is we have a poster session, and so there's literally experts in the room that are presenting on usually a service that they offer, and it has a poster, and it's someone that maybe didn't sponsor a booth, but they are a strong attender, a strong supporter of 4C, and we want to support them. And the best part about it, no, I'm not a drunk. The best part about it is there will be refreshments served from 4:30 to 6:30, so when we wrap up here, if you go straight across the hall and make your round with your favorite refreshment, that would be ideal. And then tonight, I know dinner's kind of been on your own, but tonight's Fat Tuesday event that I was kind of making fun of earlier, it's not the Brazos room that's right down the hall here. It's Brazos Hall, which is literally just one block up on 4th Street starting at 7, and I'm told there will be food. So if you want to try to avoid another $35 meal, you can come on up and enjoy the evening there. And one more thing. So I was heavily involved in the applicability determination when the rule came out, and we're talking about the control requirements. And if I say something today you don't agree with, I would love to talk to you about it, because one of my favorite things about this conference is the collaboration part, to find out how you guys are dealing with these rules. Everybody has a different idea and a good idea, and you hear different things. I really enjoy those conversations, so please, if you're bold enough, raise your hand and ask in the class, or if you want to talk afterwards, that's great too. We can talk after the presentation. So I'm going to get right back into it so we can wrap up and put the big push on to the end here. So storage tanks. In my opinion, for the upstream segment, before the natural gas processing plants, this was the major part of the rule. There are really, in my opinion, two major parts of the rule, and that was controlling emissions from flowback for natural gas wells and the storage vessel requirements. So back to the control device requirements for storage tanks. Again, 95% VOC reduction. Typically in the upstream sector, you're going to have a vapor recovery unit, which is typically a small compressor that's going to take flash emissions off of your oil storage tank and route those to sales, or potentially you're going to have a flare or a combustor of some sort. And so again, the EPA wasn't super restrictive and said you have to have a flare that's 98%. You need to achieve 95% VOC emission reduction. Well, fun part of implementing a new rule, I think in the original preamble, the EPA estimated that maybe 300 tanks across the entire country would be affected by this rule. That must have been before the boom, this round of the boom with the shale boom started, because there's hundreds, if not thousands, of storage tanks that are affected by the rule. So in the first revision, or stage 1 revisions that I showed you on the timeline, They thankfully, again, in my opinion, very responsive to reality. The EPA revised the rule and said, okay, if you're after the applicability date, August 23rd, 2011, you got a new storage tank, it's greater than 6 tons per year. We realized we underestimated how many tanks, because there weren't enough flares out there, believe it or not, or vapor combustors or barrel combustors, some folks call them, to get them all installed in time. And you guys know with engineering, you got to retrofit. It's a lot more complicated than if you just build new. And so it's one of the few dates in the rule that are still left to pass. So your Group 1 storage tanks built between August of 2011 to April of 2013, you still got a couple more months to be in compliance with the control device requirements and reductions. Group 2 has passed. So anything built new, and in this case after April of 2014, you've got a 60-day window to have your controls in place. So reality is folks are starting up their new facilities with controls in place, because that's really the only way you're going to meet this 60-day requirement. So I've touched on this already. So the triggering point for controls is 6 tons per year per tank. There are, again, decline curves and reduction in gas production over time. There are once in, always in provisions in the rule, but you can remove your control device if you're consistently below 4 tons per year in 12 consecutive months. That makes a lot of sense, and again, very practical, because you can take your control device and move it to a new well that's coming online next month. And that's what folks do. And as long as you're not working over, recompleting that well, you should be fine with the 4 tons uncontrolled, and you stay below that. All right, but a kind of great lead in. If you rework the well and you do a refracturing and you have the potential to go back over 4 tons per year, you got to put your controls back on. So I really didn't see that when I was knee deep in it. And so folks got to realize there's production engineers out there all the time trying to figure out how to get that next barrel or that next cubic foot of gas out of that well. And you got to make sure that over time they don't work over a well and you're back over your 4 tons per year per tank limit. Okay, I said I was going to touch on this, and I really do want to highlight what I think is an interesting topic to discuss as you figure out how to comply with the new rule. So, the EPA did not put this in the proposed rule, the most recent one, so there were no comments. And in the final rule, because of a comment that someone made, they changed the storage tank definition, and they started talking about parallel storage tanks. So I'm just going to tell you what I think happened, but it's not in the rule and it's not in the preamble. I think the EPA, someone stepped up and said, if you have an affected facility storage tank and it's an older storage tank, but still, or maybe something's wrong with it, or more likely you have to add another storage tank to it, and it's in parallel, then storage tank A is an affected facility, storage tank B is going to share the same oil throughput, and so it's in parallel, not in series. And the total between the 2 tanks is greater than 6 tons per year. Both tanks are an affected facility, and so they added a lot more definitions around bringing tanks into service, which is actually the next slide. So let me finish this one. So you can remove tanks from service. If you close in a well, degas, like I said earlier, you do not have to comply with the control requirements, the record keeping requirements. You just got to put it in your annual report. Okay, sorry. Storage tanks return to service. So if it's return to service and you've got to immediately comply with the control requirements, the 95% emission reduction. So if it's reconnected to the original source of liquids, again, start up with your control device. If it's used to replace any storage vessel or affected facility, So for whatever reason, maybe it's a tank that had a hole in it. That's not typical, but you wanted to replace that tank, you would then, the new tank coming in would automatically be an affected facility and start up with controls. And then again, I didn't show you the definition, but if you're in this rule and have responsibilities over this rule, read the new definition for what it talks about parallel. And I encourage you to read the preamble because it talks about using this word when you're bringing tanks into service. So I don't have a nice graph. That'll be in the next round of slides that I do for these guys. But let's just do simple math. So you got 3 oil tanks, and they're truly in parallel. They equally share all the oil that comes through that entire facility. And the total emissions from those 3 tanks is 15 tons a year. 15 tons a year divided by 3, you're 5 tons per year per tank. You're not an affected facility, okay? But I think what the EPA was worried about was same example, but now let's say it's, let's do the math right, it's 21 tons per year through the whole facility divided by 3. It's 7 tons per year per tank. And so you're an affected facility. All those tanks would now have to have the controls in place, 95% emission reduction. And I think what they were worried about was getting out of the rule by adding another storage tank. So you've got an affected facility, it's 21 tons per year, and you add another storage tank and you're up to 4. 21 divided by 4 is less than 6, and you now don't have to comply with the rule. So I think somebody made that possibility aware to the EPA, and they went crazy and spent a lot of time writing a whole bunch of new definitions around parallel storage tanks. I will caution you though, under good engineering accounting practices, I'm also hearing kind of through the grapevine hallway conversations that folks didn't follow normal environmental calculation standards for how they did their emission calcs to determine if they are in. What do I mean by that? I might have mentioned it earlier, but their tanks were really in series and not in parallel. So that first tank in that 3 tank example, 15 tons per year, they took their 15 tons divided by 3 and said, we're good, we're out, we're not in. But they really, what's happening is all the oil for that facility was flowing through the first tank and then maybe overflowing or flowing into the other tanks after it went through that first tank. So that first tank is seeing all the emissions essentially from the facility, and that tank's emissions is 15 tons per year. So I think in the weeds of the industry, folks are taking another look at how did we do our emission calcs and did we do them correctly? And so I think that's, if you have different opinions, I would love to talk about it over that drink tonight. So be aware of this new requirement around parallel, and I think it just muddies the water. I think we'll have to see if the EPA clarifies it more in the future. So let's turn the corner to combustion devices and flares and things that you all are interested in this class. So if you have a storage vessel and you use a combustion device, an initial test is not required, exempt from certain monitoring requirements if the initial manufacturer's performance test is conducted. So there's parts of the rule that point to if you use a vapor combustor and it's manufacturer tested and approved by the EPA, you just use their test and you're good. You can show your 95% emission reduction or higher. Recurring tests not required. When this rule was originally proposed back in 2010, there was tons of performance testing requirements, and there wasn't going to be enough testers in this country to do them all. So they really listened to industry and said, look, we've been using these devices for a long time. Can we use manufacturer's tests? And the EPA said yes. Flares. Again, for storage tanks, initial test is not required. There's no exemption for monitoring requirements since flares cannot be tested according to Quad O protocol. Again, reoccurring tests not required. So they really backed off from the performance tests. If you use manufacturer's test, you're good. So if you do use a manufacturer's test, just please look at the manufacturer's test and make sure your facility is less than what the equipment was tested at. We don't want you to use a combustor that is, for your facility, is 3 times bigger than the one that was used in the test, and you really don't have a way to prove your emission reduction. So just that was written right into the rule. You got to make sure your inlet gas flow rate is less than what the manufacturer tested at. I think folks could get caught by that, so that's something to be aware of. You've got to have a pilot flame presence, visible emissions, very typical stuff. In this case, it's less than 2 minutes in every 1 hour quarterly. Okay, you can't see this and you can't see it in your books. What I wanted to point to, if you go to the oil and gas site at the EPA, this is the table they're updating on a regular basis. You can see barely down here at the bottom. This was just updated January 15th, and this is the EPA's list of all approved vapor combustors that are out there by the manufacturer that have been approved to show the 95% emission reduction. So very handy table to link to, and you can see they're still reviewing other manufacturers that the EPA just hasn't had time to fully review and approve. So a very useful table. Okay, storage vessel combustion device requirements. If the manufacturer performance test is not conducted, then you have to do some inspections. They're pretty basic inspections. Pilot flame presence, you know, this is when your record keeping is really going to come in. You got to do a monthly inspection. You got to make sure your visible emissions, you're not smoking. OVA, visual inspections monthly, and again, if smoking or no pilot light, you got to correct that situation. So if you don't have a manufacturer's performance test, you're going to be obligated to do some record keeping. Okay, turning a corner. I did mention this rule has combustion or control requirements for gas wells. There was a phase-in period that has now really passed. So I'm just going to quickly jump to, for wells, natural gas wells that begin production or flow back after January of this year, the recovered material must be routed to a tank, gas flow line, or re-injected into a well. So sellable quality gas must be routed to a flow line. If you've heard terms of green completions, reduced emission completions, that's what we're talking about. And for gas wells, I would say generally that's more the norm to sell that gas as quickly as when you bring the well online. If these requirements are infeasible, you can still not use a reduced emission completion, but you still have to use a completion combustion device. I gotta slow down. That is a term that is specific to this rule that I'll touch on in a minute, and you get these little with exceptions. I'll touch on those also. So for those exceptions, again, the industry, the infrastructure is just not there when they're initially developing a field. So terms in the industry, wildcat delineation or non-wildcat low pressure wells, those are exempt from the reduced emission completion requirements, and you can still use a completion combustion device. So, and basically you just don't have the equipment there to get it into a sales line. There's no sales line immediately available. That was a big, a very important, really not to stop new oil field and gas field development. Okay, completion combustion device. That's a definition written into the rule. I enjoy it because it specifically says a completion combustion device is not a flare. So why did they do that? They were trying to make sure folks controlled their emissions with 95% destruction efficiency and weren't overly concerned about compliance with 60.18. So since 60.18 is directed to flares, they basically said, look, as long as you are burning the gas and you're going to get 95% emission reduction, we're going to say we're good. And so 60.18 for completion combustion devices isn't required. The ignition device used for combustion emissions for completions not subject to requirements of the flare, I just mentioned, and must be used for the duration of the flow back and must be equipped. This is important, so it should be underlined. So a lot of debate in the industry. We have had flares out there for decades. They have spark ignited or high energy reignition, those are specifically not allowed in Quad O, and you've probably seen the FLIR VOC camera video of the flares out in the field, and there's this huge plume coming off of them. That's from a flare that's not lit, and it's basically a stack. So the EPA has been petitioned and commented to please allow spark ignition, and right now, today, they just don't trust the technology. They basically think that if you do not have a flame present at all time, you're going to have a stack out there sooner or later and not a flare or a combustion device. So what are folks doing during flowback? They're putting these large propane, you know, like your grill in your backyard, but they're large. They're about this tall, and for the duration of flowback, those propane tanks are burning the pilots to the flare during the flowback. So that's what's happening in the field to comply with this requirement. I touched on that. Okay, any questions on Quad O? I'm going to turn a corner and talk about Colorado for just a few more minutes and pass on the baton. Any questions? Okay, why do I want to talk about Colorado? They really stepped out about 2 years ago and started really making noise in the oil and gas segment upstream. And this was one of the first things that caught a lot of people's attention. It's kind of an issue of the industry, these thief hatches that are basically the gauging hatch that your loaders, your truck haulers use to take the load. They're getting left open or they're not maintained, I mentioned earlier, but this is a big number by anybody's standards, I would think. So the commission allows a $15,000 per day violation if thief hatches are found open. And those are happening. So that definitely got folks' attention. And then they have promulgated the final rules that are going to require a lot more controls and requirements than Quad O does, and I'm just going to touch on those. So why did they do it? So a lot of interesting stuff in the basis, essentially the preamble of the rule, and California Department of Public Health and Environment. Basically, I'm just going to draw your attention to this last one. They clearly said, for all these reasons, we want to expand the use of similar things that Quad O does, but we want to go much further than Quad O does. So I think it's worth going over because I think that's probably where the EPA is going to go next. So what did they do? They have a lot more general clause provisions in regulation number 7. That is their Quad O on steroids rule. First one is you got to use good air pollution control practices. So if you do have a device out there and it's not being well maintained, you know, this kind of general duty stuff, if you've been in the compliance world, this is kind of the catch-all stuff. Your air pollution control equipment must be operated in a manner to minimize emissions, including startup and shutdown. So again, just I think a lot more requirements over Quad O. Combustion device, no visible emissions. Enclosed, you can't have any leaks in your closed vent system. Interesting. So I just said Quad O doesn't allow spark igniters. Colorado does. So if it's a Quad O facility, you're going to have to use during flowback those canisters I talked about. But if it's not a Quad O facility, maybe something built some time ago, but it still got roped in under the rule, you're allowed to use auto igniters. So it'll just be interesting to see over time. I've got my auto igniter, but it's not in compliance with Quad O. So I mentioned wet seal centrifugal compressors. It's the same requirements as in Quad O, but instead of just the new compressors after August of 2011, it's for every centrifugal compressor in the field. So they just expanded it to everyone, and they gave a little bit of a phase-in, but they basically said you better be in compliance by January of this year. Reciprocating compressors, the exact same requirement that's written into Quad O, but again, instead of new compressors, it's expanded to all compressors in compressor stations. Storage tanks. Colorado did a good job of putting a definition together to cover the parallel issue. Instead of 6 tons per year per tank in Quad O, it's 6 tons per year for the storage tank. And I'm going to use the word battery, but they don't. I'll just read it. Storage tank means any fixed roof storage vessel or series of storage vessels that are manifolded together via a liquid line. So if in this example you got a water tank and 5 oil tanks and they're all manifolded together by a liquid line, then all of those tanks operated together have to be less than 6 tons per year. So a big expansion of the rule. Another one I think that we'll probably see more from a federal level is a lot of the emissions are in the first 6 months of a new well. That's when you get most of your payback on a well. That's when it's giving its highest production rates, and then it very quickly drops off, let's say 8 months after startup. So Colorado says, hey, we know this well about the industry, so you've got to control emissions from storage tank, temporary frac tanks during the first 90 days of production, no matter what. There is no trigger, but they do give you an out. If you're in an area that's not producing like you expected and the total emissions are less than 1.5 tons per VOC, you don't have to put the controls on. So, wow, all startups, flowbacks, got to be controlled for the first 90 days. Let's keep rolling. So they had a similar phase-in period. Again, I mentioned the 6 tons per year, and they wanted to allow a little bit more time for, it's the same thought as Quad O. So constructed before May of 2014, they're still giving you till May of 2015 to be in compliance with this requirement. Record keeping. There's a lot of record keeping requirements in Quad O, but Colorado went and said, like a flare management plan that you heard about from Herman, you've got to have a storage tank emission management plan. Thankfully, it could be one plan for your entire facilities, all of your storage tanks. It doesn't have to be specific to every tank, but you've got to meet a lot of the requirements to show that you're going to control your emissions and not have thief hatches open. So there's a lot of requirements in the Colorado rule to have this written plan and make sure that you follow your plan. Wow, another huge record keeping requirement. Another new acronym, at least for me, AIM, an approved instrument monitoring method. Colorado allows the use of the FLIR camera. It's starting to become a lot more popular. The upstream market is not heavily regulated from an LDAR perspective, and they wanted to allow you to have this inspection period, and you can use cameras instead of your traditional OVAs. So, please. You still got to use method 21? Yeah, I make that mistake all the time. When I first heard about the device back in the early 90s, people back then were calling it an OVA. But so anyway, so Sage is stepping into that market. There's a requirement to do your inspections in, I think, the first 90 days. So just know that Colorado's accepted the camera, and but as you know, if you know the camera, you can't tell how much your emissions are without a direct measurement. So basically, if you see anything on your camera, it's going to be considered a leak. And then depending on your emissions, the higher emissions, the more frequent your inspections need to be. Let's keep on rolling. There we go. We just touched on that. So you can still use the old method 21 with a TVA, or you can use the camera. Yep, that's right. So I think that's pretty self-explanatory. Again, basically by your emissions, how often you have to do these inspections, how often you have to do your visual inspections, and then a phase-in schedule. So a large part of the Colorado rule. All right, I went through that pretty quickly. Any questions? I'll just close on, I'm the non-Atlanta flare guy. I enjoy the work a great deal. So I kind of told Herman and Troy and some of the other flare guys, if you're on the Gulf Coast anywhere and you want to talk flare issues and we can't get them cornered, I'm happy to talk to you guys. And then as far as the oil and gas segment, that's something with Inside Sage that I'm trying to promote and grow within the company, so I'm definitely interested in talking to you about that work also. Are we good? Yeah, question.
Remember your definitions?
Yeah.
Comment I will say is that modification definition is going to be different for natural gas processing plants.
Okay.
So just for your info,
Oh, that's good.
go strict quad O from triple K. So
Okay, quad O from triple K.
Right.
Definition of modification for natural gas plants.
Right.
It's different.
it's different.
All right. I'm going to write that down.
It's law, okay?
So our oil and gas essentials class, we have a section on triple K, so I'll take a closer look at that tonight. Thanks a lot. Thanks, everybody. That one. This one?
Yep.
All right, awesome. All right.
Okay. Awesome.
On and on.
Okay, so 2 more modules to go. This one's going to be, we're going to touch on it. We're not going to go hugely deep into depth because it's touching on a lot of concepts that we've already talked about. It is MAC-CC, and these are the proposed changes. This was first issued in May, published in the Federal Register, and comments were due. Comment period got extended, but comment period's over now. So we're expecting, right now we hear that they're looking like a final rule is sometime in June. So it's coming soon, but it's not here yet. So it really goes into the operating and monitoring requirements around flares. It is very similar to the consent decrees in the types of things that you need to do. One of the big things that the EPA put forth is that they say that the current requirements for flares are inadequate. They basically say if you're just following 60.18, you're not doing everything that needs to be done to stay in compliance with your flare. Since the flare is used as an air pollution control device, you have to get that 98% HAP destruction efficiency. So they're definitely moving down that path of saying, okay, now we're going to put some requirements on it that you're going to have to meet. Kind of touched on this earlier, is as everybody is pulling more and more material away from their flare, that's where you're going to get right to that edge where you're going to have a hard time meeting the combustion requirements. And that's why you need an automated system looking after it. This is something that an operator cannot deal with by themselves when they're running the rest of the plant. They can't also spend a lot of time on the flare. They say that over-assisting is exacerbated and it leads to combustion efficiency degradation. We know this. We talked about this all day. And one of the things that we liked was this 98% HAP destruction is now the MAC floor. And this was kind of an interesting thing because, you know, how do you set a MAC floor? I mean, you need to get, what I said, 10 to 11% of the industry following a certain set of control. Well, how did they do that? Well, they did it through enforcement. They got enough flares in a consent decree that got them instrumented in controlling their flares. They want to come out with a new rule, and voila, you have your new MAC floor that everybody has to now control to. That's why we see that through, you know, the ethylene ICR and the rapid enforcement activity around ethylene producers, we see that there will likely be, you know, them pushing very hard to get these ethylene flares into some consent decrees, get controlled in this manner in order to say, voila, we have our new floor for the ethylene max. So we kind of see that that's how they're going about this, is they want to do a new rule and they need a new floor, so they're doing that through enforcement. They basically said they are not going to revise the general provisions. They made the statement that, well, this will draw in too many other industries if they went in and changed 60.18. And part of me says, well, why don't other industries have to control their flares the way that refineries would have to? That kind of seemed like it wasn't why some other industries would be let out. Maybe somebody has a good rationale. I haven't come across it yet, but probably never will. They've made some rules on halogenated vent streams, added new requirements on pilot flames, visible emissions, flare tip velocity. One of the things, you know, these are all those same things that we've had out of 60.18, but they're doing something a little different with this. They are kind of what I like to say decoupling max EC from the general provisions. In all the rules, they're saying we're going to remove that statement that says you should follow 63.11. They're removing that requirement, instead putting the requirements to follow the provisions in max EC instead of pointing you back to 63.11. So it's definitely, they are removing those duplicative requirements. And then they've added some new operating requirements. Two of them we talked about. And so, you know, before this came out, everybody with the consent decrees was getting pretty comfortable about what was EPA looking for. They're looking for knowing the net heating value. They want to know the lower flammability limit. And then they threw in this guy here, the total combustibles fraction, and we all said, what? So at least we can be glad to know that we are now again at the forefront of flare knowledge, and we are getting shown new concepts that hadn't been discussed before. So this is an exciting time to be in this world. A couple new definitions, and really were for flare vent gas. They pulled in the supplemental gas, so they definitely wanted. They changed that kind of designation. They were not including pilot gas or assist media in the flare vent gas, but then the vent or the assist gas is included in the combustion zone gas, but they are excluding the pilot gas. They pulled out any addition of the pilot gas. So before, when we were talking about how the consent decrees calculated things that had the pilot gas added, they're stripping that out. They don't want to have that gas in there. They also added in for the steam assist. They've talked about, they've added this premix assist air. They also have a concept of perimeter assist air. Again, all kinds of new terms that haven't been used, but they are using them in this rule. Halogenated vent streams. Basically, they're going to make it so you cannot use a flare to control halogenated vent streams. We're probably thinking that they did this for dioxin furan formation. We don't know, because guess what? They said nothing in the preamble about why they're putting this requirement in there. So they just kind of put this requirement in there, but didn't tell us anything about the why. Biggest concern for refineries is fluorine. You know, you have an HF alky unit. You have HF now, you have a halogen that could potentially get sent to your flare. Suddenly you could have some issues. Pilot flames. Again, they're got to have that pilot flame at all times. But now they're adding an additional requirement. They're not only do you have to have a pilot flame at all time, you have to have an automatic reignition system to relight your pilots. It's no longer, I have a flame front generator, if the pilot goes out, I get an alarm, call the operator, he walks over to the panel, mixes the gas and sends it up there. They say that is too long. They're very concerned about any periods where you could not have a pilot flame on your tip. So they want those systems to be automatic. For newer flare tips, these have been, you see pretty much standard now is the high energy igniters on your pilots. So for newer flare tips, this isn't a big issue. A lot of your older ones, there's no HEI up there. You have the old style flame front generator, but those can be retrofitted for the control panel down at ground level to turn that into a automatic system. So it just takes some money, but it is a doable solution. Okay. Visible emissions. They added some extra requirements. Still concerned about smoking, again, keeping the 5 minutes in any 2-hour period. But they added this requirement for a daily 5-minute method 22. And you're like, okay, we understand that we're going to be now operating close to the incipient smoke point because we want to have good combustion. Okay, now daily you have to go out there and look at your flare. The thing that made everybody kind of say this is going to cause some problems is the middle one here. So if you see visible emissions, or the public notifies you that they saw visible emissions, you need to now begin another method 22, a 5-minute method 22. And when you think about method 22 is, part of it is that person who's looking at it needs to be knowledgeable in doing an evaluation for visible emissions. How many people in the public are knowledgeable about a smoking flare? That's going to be interesting. And if you see visible emissions during your, I think it's for 1 minute in that 5-minute period, you now are extending your method 22 for 2 hours. I mean, I know that, we always have just a ton of extra people around the refineries that just have nothing to do other than stand around and stare at the flare for 2 hours. I mean, pretty much when you bring this up, I think it's a big game of not it, because nobody wants to do it. We've heard, we've seen some interesting solutions. One of the things was, well, who is at the refinery and who has time to stand around and maybe look at the flare? And one of the interesting things that came up was, well, the security guards are there. They're always there 24/7. So sure, if we need to do a 2-hour method 22, we'll just train up the security guards and they can stare at the flare for a little while. So, we're, again, this is a proposed rule, so everything I'm saying here is not final. Hopefully people commented during the comment period and we'll get some relief on some of these things. But that was one of the ones that kind of made us shake our head. Flare tip velocity. In the preamble to the proposed changes, they spent a lot of time talking about how they're very concerned about liftoff. They're not very concerned about low velocity coming out of the flare, but they're very concerned about high velocity. They took away, because again, they're going to decouple this part from 63.11. So all the equations that you can use in 63.11 and the different flare types and how those all have different requirements, they're removing that tie back. So now they said, well, you know what? We're going to pull all these equations into one equation because we say that really it doesn't make that much difference. So we're going to have one flare tip or one equation for all the different flare tip velocities. But what equations you can use again is tied to the type of monitoring you've installed on your flare system. If you have a way to if you use the total hydrocarbon analyzer system, then you're stuck below 60 feet per second. If you want to get above 60 feet per second, again, you're limited to the 400 as always, but then you can if you can calculate your net heating value, then you can get a calculated Vmax number. So that again, if you want to be able to get up that fast, it's going to drive the instrumentation selection in a certain direction. Here's the equation they used. Looks very similar to the one that's in 63.11, and it's not very different because all they did was they changed the units. The original one was in like megajoules per dry standard cubic meter. They just changed the units to BTU per scuff. So it's made it a little easier, but everybody looked at that and said, I wonder where that came from. And we all got thinking, where'd that 1212 number come from? Because we've seen that before, but it's just a happy change of units. Okay, also with the flare tip velocity, they also said that, you know what, refineries, your flow coming to your flares is highly variable. So, you know, before where you just had to do a one-time performance test for 63.11 to demonstrate that you can meet that exit velocity, we think that's not strict enough. You need to have a way to show compliance with your exit velocity requirements at all times. So they they said, so you're going to be putting, through the rule, you're going to be putting a flow meter on your flare. Well, you're going to use that volumetric flow with your tip cross-sectional area, and you're going to have to now continuously monitor for exit velocity. So they've tightened down that requirement. They did put in if you don't put in the flow meter, you can use pressure and temperature monitoring with engineering calculations to determine velocity. I think that's probably not going to be used all that often because there's so many needs for that flow meter. So I don't see that being used a lot, but I'm sure somebody will. Okay, for the operational limits, again, we talked about the first two already, and now we have a third one to come talk about. But the biggest thing that all of them are is how do we make sure that there's enough combustible material up at the tip to have good combustion? That's what all these parameters are focused around. These equations look pretty familiar. Everybody, yes, yes, good. Everybody was paying attention. Good, good. So I won't talk about those. So we'll spend a little more time on this combustibles content. Basically is taking all the carbon species that you have, and it's basically a carbon count. So you're using all the compounds with this carbon mole number, and you're basically saying, I have so many carbons up there. You normalize the propane, add in the hydrogen, and that's your combustibles content. How you do this monitoring for combustibles content is not exactly known, because most things that speciate out will give you everything. So why would you stick to just the hydrocarbons and hydrogen? I don't know, but this is an option. Here's just the equations. They also have them on a volumetric flow basis, so you can do that instead of on the mass basis. Then the numbers. So this was the good part. Before, remember, we talked about the net heating value CZ limit, that variable changing, ever-changing parameter that you had to chase to stay above. Well, now they said, we're going to just give you a number to shoot for. So thank you. That's going to simplify our control logic greatly, make things a whole lot easier. But, you know, to make things even more complicated, they decided, well, we're going to throw in this hydrogen-olefin interaction. Basically, kind of, you know, we were talking about the propylene hypothesis where, you know, you have this degradation of combustion efficiency a little bit earlier. They've now kept that concept going by giving you higher numbers or more stringent numbers to have to reach. If you meet these three, you have to meet all three of these conditions before you're considered a high olefins flare. Scott Evans tomorrow on his discussion, I'm pretty sure will be soundly picking apart the data that they used to determine this and how that it is not really sound science. So that'll be exciting. But yeah. That's basically what I went through. Okay, so there's different ways to determine whether or not you are a high hydrogen or a high hydrogen olefins flare. One, you just say, I don't even want to look to tell. I'll just follow those higher limits. I'm sure that people will be looking. But you can just assume you've got the worst. Or then this is also without just going ahead and monitoring for it, so you know whether or not what your olefins and hydrogen concentration are. Or you can do an engineering calculations based on sampling for 14 days or 7 flaring events. So there is a way to say, you know, I don't want to put in the monitoring to determine whether or not I'm going to have this, so I'll just take some samples. As long as they're low, we'll go for it. Yes? Daily samples. Yes. You know, I don't know that they, I'd have to look at that, but I mean, it's generally going to be, you know, per like method 18, which has alternates. If you ever want to really get into the weeds, go look at method 18 and understand how you can, if you follow just strictly method 18, how you can grab a sample from your flare. It's using, you're not allowed to use a Suma canister. You have to use a Tedlar bag. That kind of causes some problems because the hydrogen leaks out of a Tedlar bag. So that's not a good thing. There have been alternatives that have been proposed to the EPA which have been accepted, which allow Suma canisters for getting those samples. But if you just go straight to the method and look, you won't even know that there's these alternatives. You have to go to a specific website where they're all posted. And that's what I'll be talking about tomorrow as part of my presentation. Okay. So, you know, so they gave you those three options, the net heating value, the LFL, or the combustibles content. And they were nice enough to say, you can pick which one you comply with. We're not going to force you down one path. You can pick, or you can comply with all three. It's kind of up to you. But it will kind of push you towards what monitoring you're going to put in place. And then this was also that they were proposing that you would do some sort of initial performance test to determine which values you were going to follow. So I mean, that's kind of you're going to have some potential performance testing that may need to be done. But again, we'll see what happens with the final rule. Okay, so looking at the different monitoring methods and which way you can go. You know, for the monitoring methods here, we say chromatograph, but this could also be your mass spec, your FTIR, Raman, you know, anything that can give you that full range of composition that allow you to comply with any one of these. If you install a calorimeter, that's going to put you into the net heating value requirement because you won't have that speciated data. And then a device that, for the combustion zone limit, it's just a device that directly monitors the total hydrocarbon content of the flare vent gas. So my first initial thoughts were something like an FTIR, which is good at measuring hydrocarbons, but then FTIR isn't the best with hydrogen, so I don't know that that's really the solution for that one. That's why I've been having a hard time coming up with that. But some of the things will push you also in different ways. One of the things is if you have a high hydrogen flare, they do not give you that 1212 number that was in the consent decrees. So this net heating value in the combustion zone may not be your best option because you're stuck with the 274. That's where, but if you look at the LFL or the combustibles content, suddenly having a high hydrogen flare is not an issue. So I mean, just kind of, if you have a specific flare that's got some of these, high hydrogen is just, if you got a high hydrogen flare, you're just into a totally different world where you got to think about things a little differently. So take the time to go through that. Okay, a couple of different, they added, and one of the things with this rule was, and just by seeing how they wrote it and the things they said, they wrote this rule for people to use GCs to comply with the rule. I don't necessarily agree with that, just because of it's good, but it's not the best. People are seeing, as we're implementing more and more of these systems, that response time becomes critical. So I mean, but the EPA seems to have it in their minds that the GC is the way everybody's going to go. And you saw that with JA in that they kind of wrote some of the things centered around saying, well, people are going to use GCs, so we'll write the rule this way. But, you know, these MAC standards, you know, that's why they're updated, is because they need to keep up with technology. So why would you have a rule that's supposed to be keeping up with technology telling you have to use a specific technology? I mean, that's not letting innovation occur and getting better solutions out there. So I mean, that's again one of those things where you kind of wonder why are they forcing everybody down a path when there's a better path to be on. But one of the things that they said about for the calibration gases is you must include all of the compounds. I mean, as a consultant, early on in my career, I got beat up. Never use the word all, ever. You can, because you'll always be wrong. That's the way it is. So why the EPA doesn't understand that, and once you have to find all of the compounds, I mean, if you're at a refinery, you can have anything going down your flare header. I mean, it's just going to be everything. I mean, a lot of times that you're at some of your chemical facilities, you're kind of in certain chemicals, so it's not as bad. But, and this is for the refinery sector. I mean, they have everything coming down their pipes. Also, if you use a surrogate calibration gas, you got to go C1 through 7 of normal hydrocarbons. That's nice. You have to be online every 15 minutes. If you're going out to C7, your GC is not going to get done in 15 minutes. Once you get out beyond C5s, the run times to really get any kind of speciation of that gas takes a lot of time. And if anything comes out after C7, then you got to go figure out what it is. So again, this is so when we looked at this, we were like, are they insane? But I think it's maybe one of those things that you ask for something really bad, people will comment and they'll say, okay, we heard you guys, we'll stop at C5 plus. So then they get what they really wanted anyway with the comments. So it's like, you ask for something worse to get what you really want. So, well, we'll see. Maybe I read too much into things. For air-assisted flares, the one thing that, again, we were all on board with stoichiometric ratio. We understood it. It was in the parameters paper. The EPA said this is the way to go. Well, that's not the way that the EPA went. The EPA said, no, we are not going to use stoichiometric air ratio. And they said, because we feel our values are better. So we're like, okay, great. We're going to just have we now have a new method for calculating our air-assisted flares. Setup, very similar to the other flare limits. You have your different, but you have now these dilution parameters. And it takes into account, and what they basically said was using, just a straight up net heating value in the combustion zone was not effective enough at controlling air-assisted flares. You had to take into account the tip diameter of your flare into the equations to truly know what was going on, and that's how they come up with these equations. So you'll see, they're not that different, but they have this diameter in the equation. So that also leads to this units of BTUs per feet squared. So it's kind of like a heat flux, if you will. So again, and everything is on a 15-minute block average for all kinds of flares, and that is around. They said we picked 15 minutes because that's how fast the GC can get you data. So they came out and said it. Now we said, okay, you're going to use a GC, so a GC will give you that data every 15 minutes, so everything is a 15-minute block average. Just showing you the other two calculations, again, very similar to before. Okay, but basically, if you want to comply with this rule, it comes down to our favorite three things: 3 flow meters and an analyzer. You got to have a flow meter on your vent gas. You got to know the flow rate of your assist media. Got to know here is between steam or air, and you also got to go hear the characteristics. So either your analyzer to tell you what to do. If you're going to be adding supplemental fuel, you're probably going to want to have a flow meter on that as well. Okay. Yeah, and you're going to need to use a continuous volumetric flow rate system to determine the flow rates One of the things, like even with the vent gas flow rate, is they say you need to determine the volumetric flow rates. If you're going to use a mass flow meter, you then need to correct back to volumetric using the molecular weight, not the molecular weight from the flow meter, which if it's an ultrasonic you would get it from. You have to use the molecular weight from your composition analyzer. So that's another little nuance. Oh, this was the great thing that we all cheered a little bit. They talked about momentum flux ratio, and they basically said, you know what? The research, it was on small flares. It's not representative of the flares that are out there. The test showed good flare performance. They didn't see where the crosswind was really the big driver. So they did not put any MFR requirements in max EC. So we all said, thank you. Because you end up, when we've seen it been put into practice, the amount of gas that you have to add to overcome some of these MFR requirements is a huge quantity. We're talking probably on the order of $1 million a year. So that is not an insignificant amount of cash. And they kind of commented that since we don't think this is an issue, we don't want to make you put a bunch of extra natural gas into your flare to overcome something that isn't important anyway. We don't want to increase emissions, we want to decrease emissions. So if you, but you know, like any rule, you know, the flare here is not a affected facility per se. It is brought into once you have some of these affected facilities using the flare as a control device. That brings you to the party. Okay, one thing they did, which again we all marveled at, was in proposing rules to a Part 63 rule, they added changes to a Part 60 rule. So we were all just like, thank you for adding another complexity into the regulatory soup that we have. And their comment was, well, we felt we needed to put these in with these proposed rules because we thought it'd be too confusing between the two different rules. And we're like, well, that really didn't solve the confusion. But they did it. But the changes weren't significant. They basically are removing, the biggest thing is they're removing this distinction between flares that receive routine flow versus not routine flow. It had to do with performance testing. They basically are saying they're taking that out, so everybody has to. They didn't want to say if you don't receive routine flow, you don't have to do something. They basically took that out with some other minor variations. This, I'm not going to go through this in any good detail, just kind of showing you that, you know, the amount of time that you have to keep your data sets for. You know, just to the 2 to 5 year time limit, you know, pretty standard. Okay, so continuous parameter monitoring systems. Since it's all these things that you're putting on your flare are not actually measuring the emissions coming out of the flare, they're not ASEMs, but they're measuring parameters, so they're a CPMS. Well, like I said before, you got a rule, what do you got to have? A plan. You always got to have a plan. So you're going to have a plan to, you got to document all this monitoring, all the calculations and everything. So I mean, going through the requirements for this plan, it is not just a fill out a form and send it in. This is a highly detailed plan. So it will take significant effort to create this. You're going to have, you know, and it's going to incorporate the QA/QC requirements. And luckily, you don't. You just have to have it on site, and you only have to submit this plan if requested by the administrator. I know different states are a little different. Some states require these QA/QC plans to be submitted to them for approval, but that's state specific. And let's skip that. They, you know, started talking about all kinds of rounding and data reduction. I'm not going to bore everybody about that, but they took the time to include it in the rule. Oh, this was one that we were so frustrated about again. You know, because enforcement, again, knows about the flow meter accuracy issue. We need the 20% from 1 to 0.1 feet per second. Did they do it with the proposed rules for max EC? No. You know, even with the comments that went back on NSPS JA about the flow meter requirements, they did not change it. They still went with this 5% over the normal flow range. So it's still going to be an issue. I'm sure that people have commented on this for the rules. So we'll see what comes out of that. Pretty typical. GC's got PS9, calorimeter plus or minus 2%. So it's you know, this one's the big frustration. Okay, I did that very fast because I know everybody is tired. So I got one more section, but are there any comments on CC?
Timing, what do you think related to hearing on?
It was June. It was originally it was supposed to be May. Now we're hearing June. So it keeps getting dragged out. Okay. Okay, so this is kind of just to wrap up. This is you know, kind of just what we hear from dealing with everybody and just trying to understand kind of where things are going. So just I'll leave it at that. We'll talk about just kind of you know, with the ethylene MACT ICR, you know, seeing the EPA, you know, kind of, well, they're not wrapping up with refineries. We do know that there are going to be additional consent decrees with refineries, but we see the interest focus at going into chemical plants. We see a lot of 114 requests going into the chemical plants, asking a lot of flare-related questions. We'll talk about what happens, you know, where we'll talk about some of the consent decrees, just some of the things to be aware of. I'll pretty much skip over the preparing for NSPS JA because we've already talked about JA, and you better be moving very quickly right now if you haven't started yet. Okay, so we had a lot of questions submitted by API on the reconsideration of NSPS JA. They're not going to reconsider JA, but they have a lot of questions to ask. Oh, and I love this picture. You think any one of those are having good combustion? And just I hope this isn't your flare, but having flares next to each other, it's a very bad idea. Just because one needs maintenance, you can't do maintenance on one without all of them going down. So generally, some people say they can save money by putting them all in the same support structure, but it's generally not a good idea. Document on flare. Okay, there was a a document that came out, the parameters paper on flare enforcement. It came out from EPA, 225 pages, peer reviewed, a lot of comments from that. But we've seen now with the proposed rule for max CC that they've kind of not even followed that document, especially when it came to air-assisted flares. One of the things that we kind of see as a frustration out there is, you know, back in time, you know, there used to be this thing, advance notice of proposed rulemaking. You know, EPA would be thinking about putting out a new rule. They would put out the new rule. They wouldn't propose the rule. They would kind of just, you know, tell people about the rule so industry could look at it, comment back, work out you know, any changes, significant changes that they saw. Lately, we pretty much see that doesn't occur. It's pretty much we don't hear a lot coming out of EPA, and suddenly there's a proposed rule with a 60-day comment period. So it's kind of, there's an uneasiness with that, in just that industry doesn't feel like they don't know what's coming. And so people don't, some people, you know, we talk to a lot of people and they say, you know, yeah, we talked about combustion efficiency, and they say, yeah, these are good things, and, you know, we would even be willing to, you know, install some of these things, even now. But they say, when we don't know what the requirement's going to be, we don't want to put anything on now, because we don't want to put it on to then find out we put the wrong thing on and have to do something else. So there's, you know, some people are holding back from maybe operating their flares better, because they need some more comfort in knowing that what they put in will keep them in compliance. Okay, preparations, and this is for, we say for a flare inspection, but really it's also for a 114 request. Go to your plant, find your information. Find out what instrumentation you have on your flare. What data do you have? Where is it stored? How can you get it? These are things, when you get a 114 response, it comes with a standard 30-day period to get those responses in. For, we've seen upwards of 30 questions, you know, going back 5, 10 years. That's a lot of information to pull together in 30 days. You can ask for an extension, and we highly recommend you do so. EPA so far has not denied extensions. They generally like to see something, information coming to them, so we see a lot of people going with a staged response. It's like, well, we can't give you everything in 30 days. We can answer these 10 questions in the 30 days, and we need another 30 days for the other questions just to get all that data together. And they've been generally receptive to that sort of staged approach. But they won't extend you indefinitely. There will be a, you got it, because it's also a kind of thing of, are you taking this seriously? They want to see that you've taken their request seriously, and you're going to be giving them the data that they need. And also, it's not only the data, but it's also your documentation. Do you have a copy of your latest flare tip drawings for the tip that's up there? That's one thing we've come across is, yeah, we got these 3 or 4 drawings, yeah, for various tips, and basically we rotate them. You know, every so often we take one down. It's getting worked on in the shop while we put up this other one. Yeah, that's a zinc, that's a Zico, that's a Calidus. Which one's up there right now? I don't know if we know. Well, this one says you have a minimum steam of 600 pounds an hour. This one says 650. That one says 800. And you're just like, okay, so how do we tell the EPA what's the minimum steam for the flare that's up there now? You know, these are some of the things that you have to start thinking about. Yes, there's a lot of things you're supposed to do. They don't always happen. Or it's just that, and I'm not saying we do see times when things get lost. So you don't always have this data. Also, some of these older flares, you know, the base flare stack and all that was put in back in the 70s. Is that even available anymore? You know, maybe the latest flare tip information is there, but the rest of the flare information may not be there. Things get lost over time. We see all kinds of stuff. You know, we kind of like to say, you know, it's a good thing to kind of do sort of one of these gap assessments, is go into your facility and look and say, if we had to comply with JA or Max EC, you know, tomorrow, what do we have to do to get there? And that can kind of focus you in on, we need a flow meter here, we need better control here. It's kind of getting yourself in that mindset so you know what to go after. Another thing is operations training, getting your guys away from just jamming the steam on. Because really, it's the whole thing is, they turn the steam on, when did they turn the steam off? That's why the EPA wants these automated systems put in, because you find too many times that there was an emergency, smoking flare, steam went all the way up. They're dealing with the emergency. Emergency's over. What triggered the operator to go back and turn the steam down? Was it 10 minutes, an hour, a day, a month? Did it ever get turned back down after the last upset? That's kind of where the EPA's concerns are. So it's one thing though, TCEQ put together an online web-based training program. It takes about 3 hours to go through. It's a bunch of different modules, get a little quiz at the end of each module. It talks about a lot of the concepts that we've talked about today. They get a little certificate that says they completed it. But it's a good thing to have them run through just so they can see these concepts, see some good pictures of what a properly operated flare looks like versus an oversteamed flare. So that's something it's available to anybody. It's free. So I highly, and I believe it's open source, so that if you want to take their training, maybe add some stuff, maybe take away some stuff, you can put on your own training with their materials and customize it for you. So they made it really easy for you. And just also looking at your procedures around your flare. There's a lot of times that written procedures aren't out there. And it's sometimes a good thing to have a procedure to point to tell the EPA, yes, we know how to operate our flare because we have a procedure for it. A lot of times there are no procedures around that. Okay, one of the things we always like to show is, 60.18 is 3 pages in the regulations. It's 907 words if you count the headers and footers. Comparing that to here, we'll just say Marathon's flare CD, which was 196 pages for the flaring requirements.
That's for flares, and that's for only flare.
Yes. Yes. Well, they have other things that they had to deal with, but the flare parts were 196 pages. So, I mean, and it had 98 definitions of terms. So, I mean, and this is not uncommon. I think, did we have it? Yes. Here are all the other ones, and you can see page lengths compared to 3 pages for 60.18. So there's a lot of more information and things you have to do around your flare. The other thing everybody likes to ask about is the penalty. And everybody sees the big one, the $8 million for the BP refinery. That was for one refinery. Here for Marathon, this was for 6 of their refineries. So I mean, it can vary. One thing here you can also notice are these enforcements. These are called CAFOs. They're consent agreement final orders. They are different from a consent decree. One of the greatest things about them, they self-terminate in 1 year. A consent decree, you got to come into compliance, do all this stuff, and then you got a petition to get let out of your consent decree. The CAFO, as long as you've met all the requirements, automatically terminates and you're out of that party. Some of the other interesting ones, these have all pretty much been, Afton was a chemicals, Country Mark Refining, Shell Deer Park was one of the more recent ones. That is for both, it's a co-located facility. It's both the refinery side and the chemical side. Both were pulled into the consent decree. One of the interesting things about that facility is it had some interconnection between the chemical side and the refining side for the flares. Those had to get split out. They weren't allowed to send chemical constituents to a refinery flare, and vice versa. They had to pull those two segments apart. And then Flint Hills Resources, again, is a chemical consent decree.
Shell, they're actually called an environmental group, the consent decree environmental engineers. And I think, I know I've met one, I think there's 3 people, full-time job, to comply with that.
Oh yeah, and there are a lot of facilities here that when they got into their consent decrees, they have a full-time flare coordinator now. It's a person's job to deal with the flare all the time. So I mean, this, especially during this the implementation period, there's a lot of work that goes along with it. For a consent decree, it generally follows this basic structure. There's some things that are in some, not in others. But two of the big things that you will always have: instrumentation and monitoring. They're always going to have you put in monitors and all that stuff. And then the other side is they are always going to have a minimization step. So it's instrument and minimize is what's common to all the consent decrees. Whether or not you had to put in flare gas recovery is not constant over all the consent decrees. Some required it, some did not. Some have, doing some performance testing. Like I said before, they kind of had more of that in the beginning when they were learning more about the flares. Now that's pretty much, if it's a steam-assisted flare, they're not asking for it. We're looking to see for the next ones, if for the air-assisted flares, if that comes in. We talked about instrument downtime and having stipulated penalties based on downtime, based on being in control. Some of them, for some of the refineries, it had in there, well, guess what? You get to take JA applicability regardless. And then this final one, if you get into a consent decree, don't think that you can terminate your consent decree and then go back to normal. The last step of the get out of the consent decree process is take all of the requirements of the consent decree and put them in your Title V permit, where they will live on forever. So you don't ever get out of that trap. You get out of the stipulated penalties, but you don't get out of the control requirements. The other thing too, I skipped over here, was the flaring limitations. We've seen definitely on the refinery side that they put on a hard flaring cap on the facility. They include a nice equation. So if you want to take your facility and see what your limit would be, you can do that. It's based primarily on throughput and the complexity of the processes you have at your specific refinery. Okay, I know you can't read this. I believe it should be one of the handouts, so you can pull out and look at these things in detail. I just want to talk about, I'm trying to think of what are some of the interesting ones. Here you can see with the steam to vent gas ratio, Marathon had a volumetric basis, pretty much went away for the rest of them. They all have the consent decree, or the combustion zone limits. They got their limits. Momentum flux ratio, that was primarily Marathon and BP. Country Mark didn't get it. And while Country Mark didn't get a specific number they had to shoot for, they have the requirement to, if they see discontinuous wake-dominated flow, they need to control for it and remedy the situation, i.e. add supplemental fuel. But so we're saying, how do you comply with that? What's going to trigger? Because people, unless you have someone staring at the flare 24/7, how are you going to know when you need to add supplemental fuel? So we felt that they're going to include some sort of calculation of MFR in order to put some type of alarm into the system to alarm and tell the guys, hey, we're approaching where we think MFR might happen or be a problem. Look at the flare and see if you need to adjust anything. So we don't see that really got them out of calculating MFR. Everything else is pretty consistent on this one. They had in the beginning on Marathon and BP for the flow meters, they were requiring the dual path, dual channel flow meters. I think that was kind of them getting used to that technology as well. But now once they've become comfortable with it, they haven't required it for anybody else. Anything else really? Yeah, nothing. Oh, the video camera. everybody says, okay, great. Most people have a video camera on their flare already. What's the big deal? Well, the big deal is whether or not you have to record that data, record those images. You know, here we got for Shell and for Flint Hills, you have the requirement, you have to save 4 frames per minute. And because, you know, these are compliance reasons, you're going to have a nice high definition digital image that you're storing. I know data storage is cheap, but this is a large amount of data, and these data storage systems are not going to be inconsequential, we found out. So that is why if you can push to not have to record those images, could be a cost savings. You can see here for the Marathon, BP, and Country Mark, they have to have the video camera, but they do not have to start recording until they exceed that 5% in manual mode. So I mean, there again is that big push to do not get into manual mode, because you're going to push us into a data recording issue. How am I doing on time? Ooh, 6 minutes. Okay, that's pretty much good. Just a couple differences. JAs, you know, is sulfur, consent decrees, is combustion efficiency. We've gone over that. Go quickly. Instrumentation. I mean, these are some typical lead times we're seeing on instruments right now. That's when you have 200 and something days left to go. That's a lot of days right there. So you hopefully have your stuff ordered by now. Prepare your FMP, get ready for submittal. You know, the H2S can be the driver. Compliance deadline, we already saw this. I'll skip over that. Do your minimization. Don't wait on this. This is the time-consuming part of JA. So here we kind of mapped out kind of a suggested approach as to the different things. And, you know, some people are doing some, they're not doing others. But we kind of just saw this as a progression of thought as you move through JA and potentially getting ready for some sort of enforcement action. Okay, so thank you. Any questions?
We get asked all the time, I'm not a refinery, I'm not subject to that PC or the proposed rule, I'm not subject to JA. What should I be doing? That's a pretty good list.
Yeah, and when we think about these lists is that do these things on your time, on your own schedules. You know, if you know that, you know, putting a flow meter on your flare header is a good idea and you guys think you want that data, do it in your budgeting cycle. Don't wait for EPA to show up and say, hey, you have 6 months to do it. You know, go start these projects. You know, figure out when your turnarounds are. When is that flare going to come down next time? Can you make some of these changes, you know, proactively? You know, how those facilities got into the CAFO instead of a consent decree, they were already moving down the path. They knew that's what they were doing, so they knew they could come into compliance, so they were going full steam with flow meters, analyzers, and all this stuff. That's how they were able to say, look, we know we figured out we weren't doing what we should doing. Look, we are already doing what we need to do. Don't put us in a consent decree. You know, yes, we had some things we weren't doing right. We'll pay the fine, but put us in a CAFO instead of a consent decree. I mean, but you have to be proactive in order to be able to meet those deadlines. So that's where we kind of just tell people, start. You know, we've shown the pieces. It's now just starting to get those pieces integrated into your system. All right. Well, thank you. Please give us feedback. We do look at that. And again, there's the poster session is probably, I think it's already started. Please go there, have a drink, look at some interesting posters. And then after the poster session, come to the Mardi Gras party. It's like a block away. It's not bad. There'll be food, drinks, music. I think there's a Zydeco band. So it'll be a fun time. So please come. And if you have more flare questions, I love talking about flares. So yeah. So thank you.